Hello. Hi everyone. Can you just confirm if everything is okay? Okay. Just let me know if audio, video, everything is fine. And then we will just start. So this is, the first part, and then there will be the second part. So basically, I will take, till HDT. So those who know compiler syllabus, so those they know that compiler is actually divided into two parts, right? Front end and back end. So I will be taking back end. No, sorry, front end. Okay. Okay. So now let's get started. Okay, audio is clear, right? Great. So let's get started. So this is compiler design marathon part one. Okay, so this is going to be the part one. So here I will be covering everything that is required to solve almost all the PYQs for the lexical analysis. Okay, and in the parsing, I will be covering basically you can say LL1, LR0, and SLR1 today. Okay, and first follow these things. So there will be many more insights that you already know. So basically, if you are thinking that you already know compiler design, then also I suggest you that you watch this series, okay, this particular lecture at least, okay, and then you will get to understand many more things that you might already be not knowing. Okay, so let's just start it with very basics. So here I will be starting with basics, assuming that you don't know much about the compiler, and I will make sure that you end up doing, okay, whatever questions that they ask from these topics. Okay, I make sure that if the question is not too much out of the box, okay, which in the sense that they have not asked it ever and they will ask it very first time, and then that is difficult for most of the people. In that case, you might miss it, but that is the only case that you might miss it, because covering each and every small details. Although I will be covering every small details about lexical analysis and other parsing like bottom up parsings, but still by some chance, see, here I will not be, let me just tell you honestly, here I will not be covering handle and bible prefix, and I have already covered these things. Okay, I have already covered these things, will not be covering here in YouTube lectures. Okay, will not be covering here. So apart from these two topics, if they ask anything from lexical analysis, from parsing, from these three parsing, you will be 100% able to solve all the questions. Okay, and these two topics which I have mentioned, I think they have only asked two to three questions in last 40 years. Okay, in past 40 years. So don't worry about these two to three topics. So so in the sense, you can say that I will if you attend this lecture, then you will be able to solve almost all the questions from these topics. Okay, so with that note, we will be starting. Okay, so some people are saying that I have not studied it before, so go easy. So don't worry, we will be going it very easy. Okay. Okay, so those who have not studied, let me just tell you, I will be going with very slow pace. Okay, so the pace will be slow. It is definitely for first time learners, but only request is that be attentive. Only request is that be attentive in class. Okay, and enjoy. And I will make sure actually you will enjoy. Make sure, okay, 100% I will make sure that you enjoy this subject. Okay, I'm guaranteeing it, I'm promising it, that's my promise, that if you just be in the class, you will definitely enjoy. And also we will be solving all, okay, all PYQs. Okay, all PYQs of the topics listed. Okay, all PYQs. Got it? So that you get more confidence about it. Great. Now let's just start. Okay, so now let's just get started. Okay, so what is a compiler? This is very first question that you might be asking to yourself. Okay, that what is a compiler. So let's start with the definition of compiler. Compiler is a program that translates high level program into equivalent low level program. So what do I mean by that? So let's suppose you have some C program. Okay. Then what it will do? It will translate your C program into something called as assembly code. Okay. Assembly code. It will translate your C program to assembly code. Assembly code means that it will look like, finally it will look like something like this. Move R1 comma R2, something like this. Okay. You might have heard about these symbols MOB, okay, load, store. Okay, probably you can heard about you might have heard about it. If you have not heard about this machine instructions or the assembly code, then don't worry about it. Okay, if you have not if you have not heard about it, okay, these are the assembly codes. Okay. Okay, so Varshu is saying that Varshu, actually this session is for compiler design, so I request you to not ask these questions in this particular session. So let's just stick to compiler design. Okay, generally other teachers answer questions which are not related to the particular topic. What we just want it to be stick to the particular topic. Okay, so I can answer your question that you can just mail us. Okay, so you are asking that what is the difference between the free content you are providing and 25K course. Okay, actually the obvious difference is that in the free content that is not all we are providing. We are providing just some of the topics. Okay, and this is the very obvious difference. And for more details you can just mail us. Okay, so let's get started now. Now, is this clear to everyone that the source program, whatever is language you are using, for example, you might be using C program, you might be using Java. So there are different compilers for different program, right? I mean programming language. For C programming language, there are different compiler. For Java programming language, there are different compiler, right? But ultimately, all of them are running on the same machine. So based on the instruction set architecture, actually don't worry about it. But yeah, it will be finally converted something like this. Okay. Now let's just get started with this compiler definition, that how does this compiler look like. So this is the structure of modern compiler. This slide I have taken from Stanford. Okay, these are Stanford slides. Now there are different phases in the compiler. So basically, as I told you, that you will give source code, for example, C programming code to the compiler. This whole thing is compiler. And finally, it will get converted to something called as machine code. Okay. Is this okay to everyone? Okay. Now this thing, as I told you, is compiler, right? It is having different phases. Okay. So I have listed down all the phases that it has. Let me just, little bit minimize my window. I hope this is okay to everyone, right? Okay, so I've listed out all the phases that it has. Now, as per the gate perspective, or as per the, you can say, like what gate asks frequently. Gate asks frequently from syntax analysis, which is also called as parsing. Okay, this is I can say the favorite topic of gate, or it is most frequently asked, topic. Because the reason is that there are many questions possible from this topic. Okay, others are not very interesting. Actually, lexical is also interesting, but gate has not asked much questions from lexical also. Okay, gate has asked, I think, 1-2 questions, interesting questions from lexical, but gate has many questions from syntax analysis. Okay, so these all are the phases of compiler. So basically, you will give this program. This program looks like which language program? Can you tell me? Is this a Python language program, or this is a C programming? I think it looks like a C programming language program, right? I mean, it is a C programming program. Okay, so the compiler will take this C program and will finally convert the C program to the machine code, but it has to pass through many phases, right? It has to pass through many phases. Let's just quickly see that what are these phases and how do these phases behave, or how do each of this behave, right? Each of this behave, so that you get overview of compiler, and then we will be starting with the lexical analysis, then we will be moving to the syntax analysis. Okay, so if I talk about lexical analysis, this is very interesting. It says that, see, when you read this, okay, when you read this, tell me, how do you read this? Tell me honestly. Do you read it like this? Do you read it like this? Okay, let me tell you how do I read it. I will be reading it like this: while bracket y less than z bracket, right? So see, focus on my words. I will be reading while and then bracket, or do I read I mean, as a human you read it as a while, or you read, I mean, how do your mind process? I'm asking this. How do your mind process? Do your mind process this as a while, or do your mind process like, okay, this is w and then h then I then l then e? How do your mind process? I think most probably your mind will say, okay, this is while and then bracket y less than z, isn't it? So these things are called tokens. Okay. So basically these are the logical units. I mean, logically you can say this is one unit. Okay. I mean, you will not be saying, okay, w is separate, h is separate, I is separate, l is separate like this, right? You will say while whole thing as a one, isn't it? You will say while whole thing as a one. So this whole thing, that what you are saying as a one, it is called token. Okay, token. And lexical, see, as a human you know this is a whole thing, but how do I tell this to compiler that this is a whole thing, right? See, I need to tell to compiler that this while is a whole thing, this int is a whole thing, this is not int, this is not like this. I mean, these are not the three letters. I mean, these are actually the three letters, but our intention is to treat this as a whole thing, isn't it? So I need to tell to compiler that, see, this is a whole thing, this is a whole thing, this is separate, this the by is separate, this less than is separate, z is separate, this bracket is separate. So telling this to a compiler is basically done by lexical analysis. So lexical analysis is one of the phase in compiler which says that if you give me some input, I will break it down into the logical units. Okay, into the logical units. One of the logical unit that you can easily identify is while, isn't it? So you will say that one of the first logical unit is while, and then comma means like I'm just separating with the comma. I mean, it's not like actual comma. Okay, I'm just separating with the comma. And then you will say the next logical unit will be this bracket, and the next logical unit will be by, and the next logical unit will be this, and the next logical unit will be like this. So these are the logical units. Logical unit means that this is how our mind will process, isn't it? I mean, this is our intention. So this is how human mind will process, right? This is how. But we need to tell this thing to the compiler, isn't it? So that is why we need to basically make sure that compiler know. Okay, compiler know that, okay, these are the different units. So what lexical analysis will do, it will take, okay, it will take while, and it will say that, okay, this is a token. I mean, you can have any representation. So they are saying t underscore while. T underscore while means this first thing will be converted to t underscore while. T underscore while means this is something while. Okay, and the second thing, which is this left parenthesis, can be converted to t underscore left parenthesis, and then this is some identifier, which means some variable name. It can be converted to t underscore identifier, and then they can also write the variable name. Okay, so basically this whole thing is a token. Okay, this is a token, this is a token, this whole thing is a token. So token generally have, I mean, you do not need to go to the detail, but I'm just telling you in one line. Token generally have two things. One is called token name. Okay, and it might or might not have attribute. This is called attribute. See, if they just write t underscore identifier, okay, and they don't write x, y, z, a, b, c, suppose they don't write something like this. In future, will you be able to identify that this is different from this? Tell me. If they don't write whether it is y, whether it is z, in future, will you be able to identify that this is different from this? I don't think, right? So in future, if you don't write it right away, okay, if you just lose this information, if you just lose this information, in future you won't be able to differentiate. So that is why some tokens, not all, okay, some tokens have attributes. So this attribute is basically a pointer generally. See, again, this is not very important. Just in one line I'm telling, if you're curious, okay, this is generally something called as pointer to symbol table. Okay, anyway, so our purpose is not to discuss these things. Our purpose is to discuss the what are the logical units. So basically, I'm sorry that I told you that information, which you might think that okay, this is very tricky or something like that. It's actually very very easy. Okay, so what is the job of this lexical analysis? Lexical analysis will say that okay, this is one token, 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 this is one token. So it will break it down to the logical units. Okay, so these are the logical units, or you can say in technical terms, you can say it is a token. Is this okay to everyone? Yes, logical units and token are the same thing. Okay, so this is called token. Now this is the job of lexical analysis, and once the lexical analysis done its job, okay, then the syntax analysis comes in. Syntax analysis just check that whether the syntax is correct. For example, it might so happen that I write okay while is a token, that is okay. Okay, I may write okay something like this. Okay, tell me is this the correct, I mean, should I be putting the opening sorry closing parenthesis before opening parenthesis? Is this a correct loop? No, right? So basically lexical analysis doesn't check whether it is a correct loop or not. Lexical analysis will just say okay, this is, see, as a human you immediately know that it is something wrong, right? As a human you immediately know, but as a machine it does step by step, and the steps are written here. Okay, steps are written here, these are the steps only. So what does lexical analysis will do? It will say it is one unit, it is another unit, it is another, right? Lexical analysis will say these are different something called as tokens. Okay, this is one token, this is another token, another token, another token, another token, another token, another token, like that, right? But lexical analysis doesn't check whether this is correct or not. Okay, it will just say that okay, these are the logical units. So that is why we have next phase, which is called syntax. Syntax means that the way you are writing, is it correct or not? Okay, so whatever you are generating, okay, in that particular order only it will go to the syntax analysis. So let me go step by step. So basically lexical analysis will give you this thing, right? Is this okay to everyone? Lexical analysis will give you this thing. Now coming to the syntax analysis will say okay, let me check, okay, whatever you are giving me, let me check whether it is making a sense or not. Okay, so that is done by using something called syntax tree. Okay, so this tree can be made actually in two ways. We will see this tree. What is this tree? I will just tell you. Maybe if you're a little bit familiar about TOC, how many of you are little bit familiar about context free grammars? Context free grammars from TOC. Okay, is there anyone who doesn't know anything about CFG, context free grammar? See, if you don't know, probably you will be able to still understand, but still if you know it, then it will be better. Okay, if you know the CFGs, then it will be better. Now this tree can be actually made in two ways. We will see both of the ways, and both of the ways are very very popular. One is called top down way of making this tree. Another one is called bottom up way of making this tree. Okay, so top down or bottom up, these are two different ways to make this tree. Okay, understood? Okay, now what the syntax analysis does? Syntax analysis will say that whatever tokens you are giving me, okay, so lexical analysis will give you the tokens. Whatever tokens you are giving me, let me just check the sequence of tokens, okay, are making some sense or not. So it will make a tree and will check it. Okay, how to make a tree, we will see this. Okay, don't worry, but at least you get to know that okay, it will check the syntax, right? It will check whether after while is this bracket allowed or not. See, after while, okay, after while, if you just write, let's suppose after while, if you write the semicolon, is this allowed? No, right? So it will just check the syntax, right? These kind of syntaxes will be checked in the syntax analysis. How? Using some tree. Okay, that is called syntax tree. Understood? So the next phase is called semantic analysis. Semantic analysis is some phase which check whether the semantics are correct or not. Okay, so it is not much important as per the gate perspective, but what does this mean? It means that it will check, for example, whether let's suppose let's suppose you are returning int from a function, and then you are basically or maybe you are not returning anything, and then still you are basically having that, okay, you are not returning anything from this function, still you are catching that in some variable, or the semantics are correct or not, right? So these kind of things. So for example, let's suppose in Python or in some other programming language, let's suppose this string, okay, string, let's suppose this is a string, and string, and let's suppose for example in C programming itself, string and integer are cannot be used with the multiplication. I mean, string cannot be multiplied with the integer, something like that. So these kind of semantics will be checked using the semantic analysis, okay, although it is not much important. And then called intermediate code generation, IR generation, okay, intermediate representation, okay. So it will generate some code, something like this, okay, which is not exactly the machine code, but it is very much similar to the machine code, okay. I mean, it help us to basically finally translate to the machine code, okay. By the way, for our purpose, as I said, semantic analysis is extremely important, okay. And then if there is any optimization required, then it will do some optimization. Then finally there will be some code generation, and once it generate the code, then it will again optimize, okay. So if there is any optimization required, it will again optimize. So this is finally the machine code. Understood? Okay, okay. Now maybe we can directly talk about the lexical analysis, and then you will get to understand about these things more, okay. So let's just directly understand this lexical analysis, and then we will be talking about the syntax analysis again, okay. So as I told you, let's suppose this is some C program that is given to you. So you remember what does the lexical analysis does? Lexical analysis will basically convert that to the tokens, right? It will say, okay, while is one token, bracket is one token, IP is one identifier, bracket, sorry, this symbol is one token, Z is one token, like this, right? So it will convert that to some logical units, right? For example, it will say, so you are giving this as an input, okay? This is just another representation. So you can say this is input to lexical analysis, right? This is input to lexical analysis. Now, how does the lexical analysis behave? Let's just see. Okay, it will read this while, it will say, okay, this is one token, this is another token, this whole thing is another token, this is another, right? So if I ask you that how many tokens are there in this particular C program, okay, this is a standard gate question. We will solve such kind of gate question also, but in gate they can definitely ask that how many tokens are there in given C program, okay, and then they will give you this program, so what is your answer here? You will say 1 2 3 4 5 6 7 8, right? So 8 is your answer. Is this understood to everyone? 8 is your answer, okay. So it is basically very much possible that they may ask these kind of questions. In fact, they have actually asked these kind of questions. We will even solve those kind of questions, okay. Now I hope that is fine. Maybe if you want, I can just tell you, okay. So they actually asked these kind of questions. See, in gate 2000 they have asked, so they are saying that given this C program, okay, how many tokens are there? Actually, this whole thing in C program, anything in the double quotes, okay, doesn't matter that what it is written there, anything in the double quotes is actually considered as one token, okay. So how many logical units you see here? So including the double quotes, it is actually one token. Now you tell me, okay, including the double quotes, actually it is actually one token. See, will this P be another a separate token, or this printf seems to be one token? This printf will be one token, right? It is a function, so this will be one token, right? This will be another token. This, including this double quotes, this whole thing is another token. So these are the 3 tokens, and then comma is another token, 4 tokens. This is 5, this is 6, this is 7, this is 8, this is 9, and then this last is 10. Okay, so how many? 1 2 3 4 5 6 7 8 9 and 10. Okay, these are logical units, or these are the tokens that we have. Understood? So as a human, you will not read it like P as a separate number. You will say, okay, printf, right? Printf seems to be very logical unit. Okay, so we want to convey the same thing to the compiler, and this is called token. Okay, this is one token. Understood? And the key point here was that anything which is within the double quotes is actually the string in C programming. Okay, is string in C programming. So this whole thing is actually including the double quotes. This whole thing will be converted to just one token. Okay, so maybe the token name could be anything, t underscore string. Okay, this could be the token name. Okay, so the token name could be anything, but yes, this will be a token. This the here the token name could be t underscore fun. Okay, and then function is actually the printf. Now it may have attribute means if there's something which is basically also needs to be conveyed. Okay, so it can say okay, printf is one attribute, okay, of this token. And for this string, this whole string is one attribute. For comma, I don't think there is any attributed needed, because comma is very much t underscore comma. It is very much unambiguously you can say okay, what does this t underscore comma mean? There is only a single meaning of t underscore comma. There cannot be multiple meanings. Okay. Similarly, for I, it could be t underscore identifier. Okay, identifier. And then it could have the attribute which is I. I mean, what is the name of that identifier? Something like this. Understood? So hence there are basically 10 tokens, right? There are 10 tokens. It was easy question, but the nice question, right? Okay. Let me know if that is understood to everyone or not. Now suppose interestingly in this particular question, okay, if I just ask you how many tokens must have attributes. Okay, so what is your answer? This is the next follow-up question. Okay, they have not asked these kind of questions, but I'm just asking you. Okay, maybe they can ask these kind of question in next year. How many tokens? See, there are total 10 tokens that you just told me. Okay, total 10 tokens that you just told me, but how many of these must have the attribute values? Okay. See, this printf is a function name. It has to be explicitly told that okay, what is the function, right? So basically, you can say this is one token which required the attribute value, right? So this required the attribute value. This is very obvious that opening parenthesis is very obvious. Maybe t underscore parenthesis. If that is the token, it is very obvious that they are talking about the left parenthesis, right? I mean there is no ambiguity in resolving it. But this string must have some attribute value. This string must have some attribute value. This comma is obvious. This I must have some attribute value. This comma is obvious. This and is obvious. This I must have some attribute value. Okay, and then this is obvious, this is obvious. So I think these are the three tokens which has the attribute values, right? These are the three tokens. Okay, do you think I missed anything? So it must have the attribute value. I think this whole thing is a string. This string must have the attribute value 2, and this could be skipped, right? Because this is very obvious that okay, t underscore comma, this could be the token name, and it is obvious that what they are trying to say from this, right? And then this must have the attribute value. So I think this one, sorry, okay, I counted it wrongly. So these are the four, right? 1, 2, 3, and 4. Okay, sorry. So yes, these are the four. Okay, so what is your answer? You will say maybe 4, right? Maybe 4. Maybe if that is needed, they will define okay that what are the possible tokens here. Okay, and then I mean they may not ask the directly the same question. They will give more information, okay, to tell you that okay, for comma they have t underscore comma, and that is the only one, okay, for comma, something like that. So that from the question context it is clear that comma is unambiguously can be coded like this. Okay, I mean there is no attribute needed for comma. Actually sometimes gate doesn't define too many things. The gate just also assume that this is obvious, right? So they may also just ask directly this question without even defining anything. Okay, so I hope you understood that what I'm trying to say. Okay, this is some points where many of the gate aspirant just by heart, and they don't know what is a token, they don't know what is an attribute, right? So how many of you have very first time learned about the attribute, that what is the attribute? No, there are like four tokens, right? I two times has come, I agree, but these are the different tokens, right? These are the different. Similarly, comma two times has come, but these are the different tokens. Okay, great. Now let's just move to the next question. Sorry, not the question, but let's just move to the next slide. Okay. So once the compiler gives you, see, we were actually discussing this. Okay, that sorry, once the lexical analysis gives you this. Okay, this is the job of lexical analysis. Once lexical analysis gives you this. Okay, this is the job of lexical analysis. Then parsing or syntax analysis will basically make some parse tree on top of this. Again, this parse tree can be made using two ways. Okay, one is called top down. Another one is called bottom up. Understood? So we will see these things later on. So yeah, let's just again do it from the scratch, that how does the lexical analysis work, right? Because then only we will be able to solve questions. Okay, so let's just start from very scratch. So suppose this is your C program that is given to you. Now you just scan step by step WHILE, right? And then you get to know, okay, this while whole thing is one token, right? And then you said, wow, I just found out one token. So that is how token generation is happening. Okay, I'm telling you currently without without, I can say, showing you much information, but we actually have to go into details of this, right? So that we are able to solve gate PYQs. See, let me just show you one of the gate PYQ. Okay, for example, okay, so for example, they have asked this question. Let's suppose, so they have asked this question in gate 2018. Okay, in gate 2018 they have asked this question. So this question is specifically asking you, do you really know how token generation is happening? So for a given string, I think they have given some string here. Okay, for this given string, how this token generation is happening, how many tokens are there in this given string, using this some formula. Okay, so to get understanding of these kind of questions, okay, to get the complete understanding of these kind of questions, we actually have to understand how things are happening step by step, right? So let's just do step by step so that you get to know very clearly that how things are happening step by step, right? Okay, okay. Now so this is one token, and now you go to the next next point, which is actually white space. But before that, there is some information that is there in the Stanford slide. So I have taken this again from Stanford slide. All of these are taken from Stanford slide. So what they are saying, as I told you, this is a token, right? So they have also said that, okay, this is called token, right? And yeah, this is okay, nice. They are also saying this is a logical entity that we read out from the source. Great. Okay, so to be honest, I'm reading, okay, this very first time. Actually, I didn't know that they are also having the same kind of interpretation. Okay, so I thought that this is my I mean, I'm basically explaining in the same in that way. But okay, that's really good to see that Stanford also have written in the exactly same way. Okay, that they are also saying this is a logical unit readout from the source code. Okay, this is called token, right? But this, while I mean English wise, if you see, at least by the English you see, right, this English wise, this is WHILE, this is T underscore WHILE or something like that, right? So you can have exactly while here also. Okay, I mean here also instead of T underscore while, you can have while itself. Okay, that's fine, but it is compiler dependent. I mean compiler can do anything, right? So basically this and this can differ. Okay, it is depending on compiler, and generally they differ. Okay, because generally we define tokens like this, T underscore something like this, right? So we call this particular thing as token, as I told you, and this particular thing is called lexeme. Okay, that's why the name, which is lexical analysis. Okay, that's why the name is coming, which is called lexical analysis. So this thing is called lexeme. Is this understood to everyone? Okay, so this particular thing is actually called lexeme. Now let's go to the next input, or I can say in technical terms, I can say this is a lexeme, right? So this is a lexeme. sometimes you discard a lexeme. Okay, so here this byte space is not needed, so I can even discard it. Okay, now let's move to the next input. So this is basically again a separate token, right, this is a separate token. And then 137, this whole thing is actually I want to read it as one token. Or do you intend to read it this as a separate integer, this as separate integer, or this as separate integer? Obviously we want this whole thing to be a one integer only. So this is one token, right? This whole thing is constant, this is like t underscore int constant, right? And it has to have some attribute value also, right? So that's why they are having the attribute value. Understood? Okay. And then some, yeah, so they have also written this, some tokens can have attribute that store the extra information about the token. Here the store integers that is represented. Okay, so the attribute can be anything. Sometimes it is a pointer to symbol table. I mean, it is just say that, okay, I don't know about this particular token. If you want to know more about this particular token, this is a pointer, go to this address, and this information is stored in something called a symbol table. Okay, so anyway, like basically this is attribute value. Okay, this is attribute value. Okay, so similarly you will be keep on scanning, and you will be keep on generating the tokens. That is how token generation is happening. Little bit have you understood that how token generation is happening? Now you may have noticed one thing, that I don't want this to be one integer, I don't want this to be a separate integer, I don't want this to be a separate integer, I don't want these three I mean numbers 137 to be the three tokens, right? I want them to be one token. But the question is that how do compiler determine that this is one integer, or these are the three different integers? I mean, how do I write something called as DFA, okay, deterministic finite automata, or NFA, non-deterministic, right? I mean, how do I write finite automata or some code to determine that this 137 is actually one integer only, right? So if you understand that how to how to basically write the DFA, or at least given a DFA how to parse this, or how to generate the tokens, then you can solve gate PYQs also. Okay, I mean, one of the kind of gate PYQs we have solved, that count the number of tokens, which was easy one. Okay, 1 2 3 4 5 like this, right? Okay, one of the type of gate PYQ we have done. But the second type of gate PYQ will be coming, that given some rules, they will ask you to generate the tokens, that how many tokens does this have. Okay, given some rules, right? Now let's just see that how to translate 137 to only one token, not to three different tokens. Okay, so are you ready for this kind of conversation? In the sense that to understand this part. Great. Now let's just move to the next slide. So recognition of tokens. Okay, how to recognize the tokens? So for example, this is t underscore 4. Now these are the two rules that are given to you. Okay, these are called rules. Okay, this is first rule, this is second rule. It is saying, first rule is saying, if FOR is coming anywhere, okay, then it is actually a one token. This is t underscore FOR, one token. This second rule is saying, basically, it is a regular expression. It actually means, okay, capital C, D, E, F, Z plus small a, okay, like this, okay. It actually means like this, into like same things, okay, capital A plus B plus C, like this, okay, to capital Z plus small a to small z, plus 0 plus 1 plus whole star, right? 9. So I hope you are familiar about at least this syntax, like plus syntax, right? These are called regular expressions. Okay, this is also the regular expression. This is one way to write the regex, that is also called regex, regular expressions. Okay, so basically the point here is that if FOR comes, then we will say it is one token, which is t underscore FOR. And if something like this, okay, that is starting from A, or I mean capital A, I mean capital letter or a small letter, or maybe underscore, okay, or maybe underscore, something like this. If something is starting from capital letter, a small letter, or underscore, and then followed by capital letter, a small letter, or some digits, and multiple times it is repeating, so you will say that it is identifier. Okay, so these are the two rules that we have currently. Now Great. So someone is saying, I'm taking the notes simultaneously. That's really good. Okay. Now let's just see. Let's just see. Given this particular input, okay, how to translate. So what do you think, by the way? How to translate this into basically, you can say, tokens, right? Into tokens. So it will be translated into tokens. So what does your intuition says? Will it be one identifier? See, this f is matching to this rule, right? So this rule is saying anything which is basically a b c d e f is actually identifier, right? So this f is matching to this rule. Is it like this? It is one identifier, another identifier, another identifier, another identifier. So basically, you can interpret. You can say, okay, it is basically up to the understanding. You can say these are the four identifiers, or you can say this is four tokens. Let me just write t1, t2, t3, t4. Basically all are t underscore identifier. Okay, this is one way to to do it, but is this correct or not, we will just discuss. Okay, but what does your intuition says? Is this correct? Or if you want, you can say this whole thing is also matching to this, right? T underscore identifier is actually matched with the whole thing. So you can say this is one token only, which is t1 only, or maybe t underscore identifier, whatever, right? T underscore identifier, right? So this whole thing is also one token. Or another possibility is that these are the four different tokens. And what is the possibility which is left? Another possibility is that this 3 is one token, right, which is t underscore 4, and this t is one token, which is t underscore identifier. So there are multiple possibilities. But which one is correct? So if I just ask you, given these two rules, how many tokens are they? If they just ask you how many tokens are they, what is your answer? How many tokens? What is your answer? Just let me know your answer. This could be the potential gate question. Okay, this could be potential gate question. Tell me your answer very quickly. Tell me your answer very quickly. How many identifiers do you see here? Do you see two? Do you see one? Okay. Most probably, this is they just mean it to be one, right? They just mean it to be one. See, in just assume C programming. In C programming, can you not give a Fort as a variable name? Int Fort. Can you not say int Fort equal to 5? Suppose in C programming you do like this. Do you really mean that okay, this 4 is a for loop wala 4? Do you really mean something like this? See, I'm just asking you intuitively first, and then I will tell you how to actually do it programmatically, or how to do it. I mean, with the logic. I'm just asking you intuitively. Intuitively, do you think that this is 4 and t? Okay, you may think it, but actually this is wrong. I mean, just see the intuition that this has to be one thing only. Okay, so how many tokens? Actually, this is just one token. Okay, this is just one token, but how to do it logically, or how to do it using the rules, that is the question, okay, that we need to answer. So basically here we got confused, right? That okay, this is like 4 3 1. I mean, how many tokens are there? So we just got confused. Okay, and this could be the potential gate question. So how to do or how to solve these kind of questions, or how to do that is called tokenization. Okay, how to tokenize this? So basically you will say that okay, you will go to this f. Okay, you will say okay, let me just see that okay, f is actually okay, o is okay, r is okay. Basically this is 4, right? This is matching to one of this. But you will not stop it here. You will check the longest one. Okay, this fourth, if you have the privilege, to match this whole thing to just one token, then it is best, right? See, if you don't have, see, let's suppose there is some symbol, let's suppose star, or maybe let's suppose at the rate. Okay, for after 4, that let's suppose there's a bracket. Okay, there's a bracket. Then this bracket, like 4, and then along with the bracket is not matching to this rule, right? 4 along with the bracket is not matching to this rule. So you will say 4 is separate and bracket is separate, right? But now if you have privilege to match the whole thing to just one rule, then you will say this is just only one token. So that is called longest match. Okay, if you can make the longest match, that is called longest match, right? That is called longest match. Is this fine to everyone? Okay, so basically we will basically have a rule which is called longest match, and there's a very fancy name of this which is also called as maximal munch. Okay, don't worry about this maximal munch and longest match name, it is just a funny name. Maximal munch is one of the name which I think I found in Stanford. I'm not sure if that is used in much places, but yeah, this is very nice name. So let's just see that what does this mean. Okay, it means if two rules are given to you, something like this, and let's suppose this fort is given to you, right? Fort is given to you, then if that fort completely can be matched, okay, the longest if that is matched to one of the token, then you will say it is t underscore identifier. This is just one token only. Okay, this is just one token, these are not multiple token. Understood? These are not multiple tokens. Now let's just understand this more. Then only once you understand about the this longest match or the maximal munch, then only you will be able to solve these kind of questions. Okay, so these kind of questions, see here, maybe longest prefix, longest possible prefix, they are also talking about the longest match. Okay, longest match. Understood? So once you basically understand this longest match, then only you can solve gate PYQs. Is this clear to everyone? So we have to understand longest match basically. There is no way out, right? Okay. Now let's just understand this longest match. That what this longest match is saying. So it is saying that given if two rules are given, then we will just match with the longer one. But as a human, okay, this is the longer one. But as a machine or as a program, how to do it, right? So that is done by DFAs. So let me just tell you how. So let's just see that how to implement. So for example, these are the two rules, right? These are the two rules. Now I will have two DFAs. For each rule, there is one DFA. For each rule, there is one DFA. Okay. So for example, for this particular rule, there is one DFA. For this particular rule, there is one DFA. For each rule, there is one DFA. Understood? Now what we will do, we will basically, okay. So for example, we will tokenize this double, right? Now how to do it? We will run. See, this is very important. Run all DFAs. So currently these are only two DFAs. Okay. So run two DFAs in parallel. Okay. Which means it is like kind of NFA, right? I mean, you can have epsilon moves here. Okay. This is kind of NFA. But yeah, for understanding, I can say you just run two DFAs in parallel. For D, you will run this also. So you will come to here in both the places. Then you go to O, right? Then you go to O. For O, you will say that, okay, in both the places you come here. Now once you once you execute this O, or once you encounter this O, you will say that, okay, see, once you encounter this O, you will say that after this do, I have reached in this DFA, I have reached here, in this DFA I have reached here. Is this fine to just stop here and say, oh, I just matched one, so let me just tokenize it to T underscore do? Is this a wise thing to do? Is this a wise thing to do? Let me know. No, right? See, what we actually want, we want to have the maximal munch, or we want to have the longest match, isn't it? So we will not see, once I reach to the final state, I will not say, okay, I will not say that, okay, I'm stopping here. I will go further. Okay. I reach to the final state, I agree. Okay, on O, I reach to the final state on one of this, but I will go further. Maybe I reach to the final state in here also. Okay, so I will go on U, B, L, E, and I found out, okay, I have reached the final state in the second DFA also. So if I have reached the final state here, then obviously I will tokenize this the whole thing as T underscore double. Okay, I will tokenize this whole thing as T underscore double. Understood, everyone? So basically the point here is that I will keep on doing it, okay, until I reach to one of the final state. But once I reach the one out of the final state, I will not stop right away. I will say, okay, let me check my luck. This is just checking my luck, right? Okay, I checked my luck. I checked my luck. I checked my luck. I checked my luck. Okay, I'm keep on going, keep on going, keep on going, keep on going. And then I finally found out, I tried my luck and I finally reached to the final state in the second DFA. So great. So I will be converting, or I will be tokenizing this as T underscore double. Now suppose this is okay by some chance. Okay, I'm not writing all the roots. Let's suppose this is DOUBE. Okay, then what will I do? I will say, okay, this is D, this is O, and then I will say that, okay, I have reached the final state. Tell me, should I directly declare after this? Should I directly declare this do is T underscore do? See, this is the second case where I have E here. Tell me. See, let me just go to the next slide. Probably you will understand it more. So suppose I have some E, okay, some other input, okay, some other input. In that case, should I be just saying after reaching here? Should I be just saying that, okay, at this moment, should I be just saying this is T underscore do, or should I try my luck? At this moment, should I say, or should I try my luck? Should I just go to U? Maybe I don't know, right? Maybe in future I reach to the final state in this also. So I will try my luck. But at E I fail. And then I actually this is something called as, keeping. I will actually there is only one latest state, or latest basically token that is required. So basically you will say that I will go back, since I have failed here. I will go back to the last step where I recognize it. Okay, that is called backtracking in lexical analysis. Although this will be, a little out of the scope, to be honest. Okay, how does the backtracking work? For this at least particular lecture, it's not very much required. But yes, I'm just saying I will try my luck. I will try my luck. If I fail, I will backtrack to the point where my last match was found, and then I will say this is T underscore do, and then I will basically run again from U. Okay, from U, basically there is some other DFA which is starting from U, or maybe you can say T underscore identifier that actually start from everything A B C D. So maybe I will just say that, okay, this whole thing is T underscore identifier. Okay, so you're getting my point? Okay, so that's the point here. You will try your luck. Okay, you will try your luck. Okay, even if you find T underscore do, you will try your luck. If you fail, don't worry. If you fail, you come back, and then you will say that, okay, this is one token, and then you will find another automata which is starting from you. Understood? Little bit you may have understood, right? Little bit. Okay, so basically my point here is that as long as you are meeting to one of the final state, doesn't mean you will stop. You will directly declare. Okay, you will always try your luck. Doesn't matter about the future. In future anything can happen. Okay, maybe in future you reach to this final state, may not be you reach to the final state. If you reach to this final state, you will say, okay, the whole thing, you're lucky, right? The whole thing is basically the one of the token, which is T underscore double, right? Okay, so suppose I have these three rules, right? Now let's suppose this double is given to me again. So now it will be more interesting. So basically, that this do is matching here, but this double whole thing is matching here, right? Whole thing is matching here. But interestingly, this whole thing is also matching to this. See, earlier the whole thing, or this particular thing was only matching to one of this, right? But it might be the case that the whole thing itself is matching to two of the things. Okay, it is matching to this also. I mean double also, this also, this also. But what do you logically think? It should be the identifier, or should be T underscore double? What do you logically think? Or it should be T underscore identifier? It is matching to both. Actually, identifier will generally match to all. Okay, this rule will match to all of this. Okay, but what do you logically think? This should be T underscore double or T underscore identifier? This will be, logically you might think that this will be T underscore double only, right? So basically, if there are multiple rules are matching, if there are multiple, don't worry, we will solve questions. But I'm just telling you, if there are multiple rules are matching, you will take the first one. You will take the first one which is matching. So using this rule, it is called T underscore double. Okay, because if multiple rules are matching, if multiple rules are matching, you take the first one. Understood? Okay. No, we don't choose randomly. Okay, we will take the first one. Logically, you might think that it is not identifier, it is a double, right? It is a double. Okay. Now let's just solve questions. Okay. Now let's just solve questions, and both of this will be clear. So you may be having little bit confusion here and there. Okay, that what is this lexical analysis, how it is working. Okay, how to solve PYQs on this lexical analysis. Now after 3-4 questions only, you will get to understand this very very clearly. So are you ready? Let me know, are you ready? For the questions, because the questions are going to be very nice questions. Okay, let's move. Let's see this very first question. This question, I think I've taken, I don't exactly remember, but most probably it is either Stanford or Berkeley. Okay, so maybe, okay, I don't have the link here, but yeah, either it is Stanford or Berkeley. So see here, consider the following flex. This is one lexical analyzer name. Okay, don't worry about this name. So they are saying they have, 3 rules. Okay, so this is called, the side effect of the rule, or maybe this is some action that is associated with the rule. Okay, so I will tell you what does this mean. So given the following input string, ABC, ABC, AA, CA. So are you able to read this clearly, or should I rewrite it? Let me just rewrite it, probably, right? So it is basically this string, right? So now they are saying that given these rules, okay, what are the tokens? So basically it will print, if this is matching, this will print 1. So A star B. So this AB will match to what? Tell me. Tell me what is the answer of this question. See, this is AB, right? I think AB is only matching the longest it can match. Okay, the longest is AB, which can match to 1. So I think you will assign this to 1, right? I mean, this is one token. Is this fine? This will be one token. Okay. So this is one token, which is basically 1. Is this okay to everyone? Now the CAA, CAA. So okay, I'm very happy to see that many people have given the correct answers. Okay, so CAA. I think this whole thing, if you just take CA, it is just matching to 2, but CAA is matching to, okay, don't worry about this A star. CA is matching to 3, right? So CA is matching to 3. So that is why you will say now the next match is 3, right? Now the next match is 3. Is this fine to everyone? And then you will say the next thing is CAC or something like this. So CA is maximum. Oh, that's great. Okay. So this is interesting. Now tell me the CA is, so this is going to be very interesting now. The CA is matching to this also, and CA is matching to this also. Okay, it is matching to 2 also and 3 also. You tell me that finally I will say what? CA is matching to 2 also and 3 also. Tell me finally I will say what? See, the CA is matching to 2 and 3. Interestingly, if it is matching to multiple, see here, if it is matching to multiple, you will say it will be assigned to the one which is defined first. Okay, so it will basically assign to this 2. That is there by default. This rule is there. They don't have to mention this rule. Okay, so it will be 2 only. Is this fine to everyone? And now this is CAA. So I think this CAA, okay, this whole thing CAA, the longest. See, Again, this CA is only matching to 2. CA is only matching to 2. But will you say this is CA is 2 or the CA whole is actually matching to 3, right? So you will say this is 3, right? So 1323 is answer. 1323. Great. I'm really very happy to see that most of you who are very first time learner are able to solve such complicated questions. Okay, so actually these questions are not easy for most of the gate aspirants, and there is a high chance that gate may ask these kind of questions this year, because gate has actually tried all the possibilities. Okay, they have asked these type of questions previously also, and gate have tried all the possibilities from the syntax analysis. Now most probably they will start asking from the lexical analysis again. Okay, so I'm very happy to see that most of you have given the correct answer. So yes, 1323 is the correct answer. Okay, and many people have given the correct answer actually. Okay, great. Now let's move to the next question. This is going to be again one question. This is going to be one question which will clear all your understanding, because it has three strings. Okay, since it has three strings, it will clear cut all your understanding, whatever concepts you should be having in the lexical analysis. All of the concepts will be crystal clear after this particular question. So maybe I have just done it in this way. Okay, this is two. Let me just, by the way, this question, these actually all of these questions are from Stanford only. Okay, as link I have written the link below. Okay, so let's do it. Okay, let's do it one by one. So let's just pick one of it. Okay, let me pick only one. Let me remove everything so that you can just focus on one. Okay, so tell me what is the answer for this. A B C C A, something like this. C. Okay, great. Now, if you notice, A star B, right? This is A star B. A star B, I think, will match to this. So, can you match to more? This is A plus B whole star and then B. Okay, great. So, if you notice this particular thing, right? This particular thing till this point, it is matching to one also and two also, right? I mean, it is matching to one also, two also. So you will give it to one or two. You will give it to one, right? You will give it to one because that is defined first. And then CC, what do you think? CC is easy, right? CC is easy. So you will match it to 3. And then A B, all B's. So I think if ending with B, right? If ending with B, A star B, 1 or 2. Okay, here only one time B. Okay, I think 2, right? I think 2. Okay, so 132. Is this okay to everyone? So let me just check. Okay, that's really great that most of you have given the correct answer. 132. Okay, most of you have given the correct answer. Let me just paste that screenshot quickly, and then we will move to the next slide. See, just have patience. We will cover everything. Okay, don't worry about the pace. As I told you, the pace will be little slow if you are if you have already studied these things. But I will make sure that even if you're first time learner, you should be able to understand everything. That is my goal. Okay, for this particular lecture. Great. Now let's just see this part. Okay, the second one. So by the way, 132 was the answer. Okay, for the first one, 132 was the answer. Let's just see the second one. So what is your answer here? I think C is only in 3. So there is no doubt this is 3. B star, right? B star and then A. What will you say? I think ending with A is nobody, right? So maybe only B star you will, ending with A is nobody. So only B star you will say this is 2, right? So yes, so this 2 will accommodate this B star. And what about this only A? What about this only A? So only A is actually not there, right? Only A is actually not even there. It has to HB. So you will say here you failed, right? None of the rule is matching. None of the rule is matching. See, the common mistake that you might do, okay? The common mistake that you might do, you may say that, see here, that I will take this as, one, or maybe someone can say something like this. Let me just okay, A star B. Actually, I was just thinking in some wrong way, where I can take this A and club with something else. But ending with A is anyway not there. Okay. So in this particular case, it is not there. I mean, my intention was to make some mistakes. So basically, your idea should be clear, that you just match with the longest one, and if multiple is matching, then you just say that, okay, this is matched to the first one. Okay, if multiple is matching. Now, if you keep on doing it, okay, you just keep on doing it in the same way. You finally encounter the A, and you realize that A is not matching with anyone. Okay, so you will say this is actually called lexical error. Okay, lexical error means lexical analyzer failing to tokenize it. Okay, so lexical analyzer fail to tokenize. Okay, it is saying that, okay, I don't know what should I do with A. I don't know what should I do with A. Understood? So lexical analyzer is failing to tokenize the A. So if you see the answer, you will say that A does not match any regular expression. Thus, this is echoed back to console. So basically, echoed back means this will be printed to console that, okay, there is some error. So this kind of error, lexical error, occurs when, let's suppose, you have in some programming language, let's suppose you say that, okay, the variable name can start with, let's suppose, A. Okay, variable name could be A. This is perfectly fine. But suppose you say it can also start with underscore. Then also you will say it is perfectly fine. But suppose you say the variable name cannot start with, let's suppose, let's suppose number 5A. Okay, suppose you have some kind of rule where you say the variable name cannot start, let's suppose, in C programming. Then in that case it will be a lexical error. Okay, this will be the lexical error. Okay, because lexical analyzer will fail to tokenize 5A. Okay, so this is lexical error. No token will be assigned to 5A. Lexical error. Understood? Okay, now just quickly tell me CBABC. So the C is only at one place, so that's why it is 3, right? And then C is actually at one place, so it is again 3. Now how many BAB? BAB, I think I can take just in 2, right? So 3 to 3. Okay, so 3 to 3 will be for the last one. This was anyway done. Okay, so this is the lexical error. Okay, so you will say this is, in this case, there is a lexical error. Understood? Now let's just move to the next thing. Okay, this is very interesting question. Okay, this is very interesting question. Let's just see this question, what they are trying to say. Okay, so they are saying, consider the following. This is, by the way, MSQ question. Okay, so don't worry about this question number. Actually, this question, I have taken, these questions from the class material, and the questions, actually, I might have solved other questions before that. So that is why this is question number 6. So don't worry about this question number, by the way. Okay, so by the way, again, this question I have taken from Stanford. This is very, very nice question. Okay, what this question is saying, let's just try to understand. So they are saying these are the rules that you have. Okay, so they are saying, since you have taken CS143, you immediately spot one or more rules that can never be executed. So they are saying that which rule will never be executed. Okay, so this is a good question actually. Just try solving this question. So which rule will never be executed? That's what they are saying. See, will this A will be ever executed? Let's suppose you just have C. because A is just matching to just C, right? First is just matching to C. Let's suppose your string is just C only. Okay, you want to tokenize this. Then, then, then which rule will be used? If your string is just C only, I think you will be using A only, right? So basically, this will be used if your string is C, right? If your string is C, this will be used. Will be using 3. If your string is CC, then what will you do? Will you say that it is 1 and 1? If your string is CC, will you say that your answer is 1 and 1? No, right? I mean, if your input is CC, you will say CC is matching to 3, right? It is directly matching to 3. For CC, this 3 will be used. Okay. I mean, never be used means whatever input you do, okay, you will never use that particular rule. Okay, you have to find out that kind of rule. So for CC, this will be used. For C, this will be used, right? Suppose your string is only A, only A. Then will you ever use this 5? Will you ever use this 5? No, right? Because this A is actually, whenever you get A, it will be matching to this also, right? So there is no chance that you will ever be using this 5. So if multiple is matching, you will anyway say that okay, 4 will be used, right? I mean, because it is defined first. So that is why I can say this 5 will never be used. Okay, this 5 I can say will never be used. Have you understood? Give me a string where you can use it, because it can be used only at A, and at A you will actually use this, right? Because it is defined first. Okay, now see here, this is A C star B plus, here this is A C plus B star. Okay, so let me take a string such as ACB. Okay, suppose the string is ACB. Since it is matching to this also, so obviously for this kind of case you will be saying that okay, it will be basically 6 will not be used. But is there any chance that you can use this 6? Suppose you have the same pattern A and then C star, right? So for C star you can have multiple possibilities. Either you don't have C, okay, you have multiple V's, or maybe A, C and then B. Okay, so these are two kind of possibilities that are only there for this 6, right? So either this kind of string will be eligible for 6, or this kind of string will be eligible for 6. So now you just see this A triple B. If these kind of strings are coming anyway, I will match to 4, right? I mean, since it is matching to 4 and 6 both, so I will anyway go to 4, right? If this C is not there, in that case, I mean, this 4 is covering more possibilities, right? So I will anyway, for these kind of string where C is not there, I will be anyway going to 4. If C is there, A, C, and then let's suppose 1 or more times B. In that case, C is there, then anyway I will be going to 2, right? So it is covering either C is not there, C is there. Okay, in both cases, either I will be going to 4 or 2. So this will never be used. Okay, and I just showed you that okay, 4 and 2 will be used for this case you will say that okay, 4 will be used. For this case you will say that 2 will be used. Okay, for these kind of strings 4 and 2 will be used, but 5 and 6 will never be used. Okay, so these two examples are basically helping me in 2, 4 and 6 in 3 rules. Okay, how? For this rule I will be using 4, for this rule I will be using 2. So either I will be using 2 or I will be using 4, but I will never be using 6. So what is the answer for this MSQ Stanford question? Answer is C and D. Answer is C and D. And this is one of the amazing question from Stanford. Okay, so Sumit is saying if A and multiple times C, if A multiple times C, okay, A multiple times C and then multiple times B, then he is saying that 6 will be used. Let's just check it. Why you will be using 6? You will be if C is coming, you will be anyway using 2, right? Because 2 is defined first. So for this particular MSQ, This is the answer, right? Have you understood? Okay. So you can say rule 5 can never be used, rule 6 can never be used, right? So they have also taken two cases. They have also taken two cases. When there is no C, you will be using this. When there is a C, there is one or more C, you will be using 2, right? So you will be either using 4 or you will be using 2. Okay. You will never be using 6. You will never be using 5. These 5 and 6 will never be used. Understood this question? Okay. Now are you ready to solve gate PYQs? Okay. So by the way, this question number is not significant because this is actually I've taken from directly from course, and course I have solved actually many questions before this particular question. Okay. Many nice questions. So maybe that is the reason that this question number is coming, but yeah, don't worry about it. Okay. So now let's just solve this question. What this question is saying, a lexical analyzer uses following patterns to recognize T1, T2, T3 over this alphabet. Okay, T1 is this, T2 is this, T2, T3 is this, right? Now, note note that X. Okay, they have just defined something which is question mark. Okay, now they are saying this X question mark means 0 or 1 occurrence. So basically, of symbol. So basically, this A question mark means 0 or 1 occurrence, right? This is A plus epsilon, something like this, right? I mean, A plus epsilon, A question mark are same. Okay, for this BB, okay, let me just zoom it out. 2 times B, I think. Just a second. Okay, or maybe I can go to the next page. So this is my string and my rules are this. Okay, my rules are this. Let me take those rules on the next page. Let's just try this. Okay, so you have one or more occurrence of A, then it is okay. So B, C, and ending with A. Okay, any number of times B, and then ending with A. Should it be T1? Should it be T1? So ending with A is basically T1, ending with B is T2, ending with C is T3, right? So ending with A. So I want this to end with A. I mean, since it is ending with A. But before that, B and C can come any number of times, and A can come so one time. So should it be T1? Tell me. So a question mark is defined actually in the question. Okay, a question mark is defined. So they are saying this actually means X question mark means 0 or 1 occurrence of the symbol X. So this is defined in the question. Okay, so don't worry about this. Okay, so tell me, is this T1? Or can I take ending till C? Can I take ending till C? Can I take this whole thing? Anything A and B and then ending with C. Anything A and B and ending with C. Ending with A is okay. Okay, but can I take ending with C? Tell me. Yes, so great. So many of you have given the correct answer. Okay, so someone is saying, please explain the rules once again. So rules are basically just like that. This A question mark, they are saying in this question that it is actually equivalent. They have defined this in the question. This is actually equivalent of saying either A is coming 1 time or 0 times. Okay, something like this. So basically I can make this as T3 and ending with C and any number of times A and B, I can again make this as T3. So T3, T3, right? So number of tokens, T3, T3, 2 number of tokens will be there. So what is the correct answer here? What is the correct answer here? See, the question mark is anyway defined in the question. Again and again, I'm saying this X question mark is defined, right? They are saying 0 or 1 occurrence of the symbol. So T3, T3 is, I think, the answer because this is the smallest one and we are getting the smallest one from the options. So D is the answer, right? T3, T3. This was 2 mark questions, right? In GATE 2018. not too ago. Okay, I can call it even recent question. Understood? This was 2 mark question. Okay, great. Now let's just move to the next phase. Or so this is done. Okay, so which is syntax analysis. Is this lexical analysis clear to everyone? Then how does this work? Is this clear, or should I give more examples? So basically, you just need to match, okay, with the maximum. Okay, so this is easy only. You just need to match with the maximum. That is all. Okay, great. Now let's just see the syntax analysis. Okay, which is also called as parsing. Which is also called as parsing. Okay. So suppose this input is given to you, and then this is just an input only. Okay, I've just written this in the continuous 1D form. Okay, so this is the input that is given to you, and then you will first tokenize it using the lexical analysis, and then you will make this parse tree. So there are two ways to make this parse tree. One is called bottom up, and another one is called top down. Okay, both of these we will study. Both of these we will study. So let's just start parsing. Okay. So this is top down and this is bottom up. Okay, there are two types of parsing. Now, before I start parsing, let me tell you what does this mean. Okay, so suppose you have any grammar. Let's suppose this is any grammar. Okay. Now tell me, is this in the grammar? Is this in the grammar? Let's suppose this is a grammar G. Is this a string in G, or maybe in language of G, whatever notation you like to use, is in the language of G? Yes, right. So how you did it? Probably you have checked that okay, S is actually producing A S, and then basically from S you can get AS, and then from this S you can again get so age as it is. You can from this S you can again get AS, and then from this S you can get B, and you can say okay, probably you will say that okay, these two A's are actually as it is. So finally you got it right. I mean basically you probably have done something like this. Okay, I'm not sure what method you did. Okay, you probably have done something like this. This is whatever you have just done. Okay, have you done something like this? First let me ask you, have you done something like this? So whatever you have just done, this is basically called top down way. Okay, top down. Okay, this is called top down. And some people okay, I know that not much. Okay, for now not much, but some people might have said okay that this maybe in the bottom of bay they have said okay, this particular B is S, and then this AS is actually again S, and then this AS is again S. I mean you are starting from this string. Okay, and then you are saying okay, this is S, this is S, this whole thing is S, something like this, right? So maybe starting from the string and reaching to the S. Okay, this is another way we will discuss, but it is called bottom up. Okay, I mean starting from the string you will say okay, this is S. Okay, now you say okay, this AS is S, now this AS is S, right? This is called bottom up. This is called top down. So there are two ways. Okay, this is called bottom up. So just recognizing that whether this string, okay, what is parsing? Parsing is nothing but checking if the string belongs to the language. Checking if string belong to the language. Okay, this is parsing, right? Again, that can be done in two ways. We will see this, right? Top down and bottom up. Okay, top down and bottom up. Okay, now Let's just see the systematic ways to do it. I mean, you might have unknowingly done something like this. Okay, S is giving AS, then this is giving. I mean, this is basically AS again, and then probably this is B, right? AAB. So unknowingly you might have done something like this. But let's just see a systematic ways to do it, because if the grammar is complex, you might not be able to do something like this very easily, right? Okay, so I mean, we will be doing this only. I'm not saying we will not be doing this. Okay, we will be doing this only in the top down, but there are like systematic ways to do it. Okay, which is called, like, systematic ways are called top down parsing. Okay, that's all. So basically if you notice here, if the string length is, let's suppose, 3, then probably you are just doing 2 3 steps, right? So basically in each step you are generating one symbol, in each step you are generating one symbol, like that, right? So you can say it is mostly in the linear in terms of the time complexity, is linear in the input length. Okay, typically it is 2n 3n or maybe n, something like this. It is typically linear in the input length, right? If input is, let's suppose, 3, then probably you have done something like this: s2 as, then as, then aab, right? So just 2 3 steps. Okay, if input is 3, input could have been, let's suppose, 5, then s2 as, then aas, then AAAS, then AAAS, then AAAAB, right? Whatever, right? So ultimately, I mean, you will be performing these many steps. Okay, so typically it requires order of n time only. Is this okay to everyone? Typically it requires order of n time only. Now, uh, so we will see these kind of things, that how to do it in order of n. But there are sophisticated algorithms like CYK algorithm. Okay, you just need to know the name of this. Probably I don't know if that is required for you in the TOC. Have you seen this in TOC? Okay, I don't think the details are required, so probably you might not have seen in TOC also. But yeah, there is some algorithm that is called CYK algorithm. Okay, that can actually parse any string, okay, without any restriction, in order of n cube. But there are some strings, or there are some grammars, okay, whose strings we can parse in just linear time, and we are interested in those kind of things. So using CYK you can do any grammar, but we will see some of the grammars whose string can be parsed in linear time. Okay, and we are interested in order of n. Okay, so there is some algorithm that can do, actually, that is very systematic way, that can do in order of n cube time for any string. Okay, for any grammar, but we are interested in the grammars which whose string can be parsed in just order of n time. Okay. Okay, so coming back to my slide, which is basically two types of parsing. One is called top down, another one is called bottom up, right? Coming back to this particular slide, let's just see. Okay, let's just see this: top down and bottom up. So how does a top down work? Suppose you have this particular grammar, and you have this particular string. Okay, suppose this is the grammar that is given, this is a string that is given. You want to check whether how to generate, using the star symbol, how to generate this string, right? So probably you will be keep on doing it. Okay, so can you tell me, from E you might go to T plus E. Okay, so how to do it? How to do it? No, you don't have to study CYK. Okay, I'm just telling you there is a name which is called CYK. Okay, don't worry about CYK. I just told you a name. So probably you will say, from E you will do T plus E, right? You will do T plus E, right? And then from this T you can say, okay, I can generate int, right? From this plus is matching actually. From this E I can again probably generate T, right? First I can generate T, and then, I mean, there could be multiple ways, but I'm just telling you one of the way. Okay, so there could be multiple parse trees actually. Okay, from this tree T I can generate bracket, and then I can generate E, then I can generate bracket. Okay, so this bracket and this bracket is matching. Maybe this E can be written as T plus E, or and then finally it is int plus int. So I have the actual diagram in the next page. Okay, so you may generate something like this. Okay, you may generate something like this. Is this fine to everyone? Is this fine? Right? Let me know. So don't worry about CYK. There is some algorithm that exists that can actually parse any of the string in order of n cube. But you just don't worry about it. Okay. I mean we are seeing where we are just interested in one linear pass. Okay. In just linear pass we should be able to do it. That is my goal. Okay. Let me know if there is any doubt till this point. Is there any doubt? So are you liking the lecture? If you're liking the lecture, then just put the like button so that it is basically recommended to many other people. Okay, if you put the like button, it will be recommended to other people also, right? So just a small request. Okay, okay. So now let's just continue. Let's just continue with the lecture, right? Okay. So there is one more parsing algorithm which is bottom up. Okay, there is one more parsing algorithm that is bottom up. So basically top down means you're starting from the start symbol and then you are basically keep on going like this. Bottom up is working like this. Okay, you start from the string itself. Okay, and then from the string you try to generate or to try to reach to the start symbol, which is E. Right, this is how the bottom up will work. Okay, you start from this input itself and then you try to generate E. Okay, so for example, in this particular case what might so happen, let me just tell you how you can generate. Can you give me the hint? From this int should you be generating E? So I think there's the only non-terminal, so we should be generating E, right? From this int this E is there, and then probably you will go left to right. Okay, you will go left to right. So from this plus there is nothing interesting. From this E again, from this int again E. So this is E plus E, the whole thing. This is E plus E plus bracket E, right? So E plus bracket E is actually giving you E. Okay, so from this E plus bracket E, this whole thing you will say, okay, this is capital E. And because you are going left to right, okay, I mean you will get to understand very clearly. Don't worry about these things, you will get to understand very clearly. Okay, and then there is again plus. Okay, if there is again plus, you will be just saying, okay, this plus is as it is, so E plus, and then there's a bracket which is as it is, so int will be converted to E, and then this is the bracket, right? And then you will say, okay, this whole thing is again capital E, right? So basically you will reach to the start symbol, and this is the bottom up. Okay, this is the bottom up. This is top down, right? So both are there. In this particular slide I have written both top down and bottom up. Okay, so which tree you want me to explain? It is just generating. Okay, E will produce E plus something like this. Okay, and then this. Okay, it is just a small intuition. If you don't get it, don't worry about it, because we will see everything in very good detail. Okay, and those who are wondering about CYK algorithm, actually it is not in syllabus. You just need to know the name, because gate sometimes may used. Okay, so okay, they have not used directly the name, but yeah, they are just saying for any context free grammar there is a parser that can take at most these many steps to parse. So this S2 is actually true. Okay, we will see about S1. We will see about the S1 separately. But is this understood to everyone that S2 is true? There is one algorithm which is called CYK algorithm that can parse, okay, in order of NQ. But we are interested, whatever in our syllabus, okay, we will see different type of parsings, okay, top down parsing, different type of parsing. Whatever in our syllabus, mostly, I'm not claiming all of the parsing algorithms. I mean, if it is non-backtracking, I mean, if it is back with the backtracking, we will see, okay, again. So with the backtracking, it might be greater than order of n, but if it is non-backtracking, okay, without using backtracking, these are order of n. Okay, in bottom up also, all the parsing algorithms are order of n. Whatever we will study, all the parsing algorithms are order of n. In bottom up also. Okay, so we are interested in all the parsing algorithms which are order of n. But yeah, there are complicated or there are sophisticated algorithms which can parse any of the string in order of NQ. But obviously we want to have some smarter algorithms, right? Yes, it is just a fact. Great, it is just a fact. Okay. So anyway, we will come back to this question later on. Okay. So just because people are wondering, that's why I told you come back to this later. Okay. I will come back to this particular question later on. Now let's just see the top-down parsing. You understood little bit what is top-down parsing. You will start from S and AS, then AS, and then AAB, right? I mean, that's what you have done intuitively. So that's called top-down parsing. Now there are two ways to parse top-down. One is called using backtracking, another one is called without using backtracking. Okay. Uh, Honestly, they have not asked any question. I think maybe one question. I don't. I have not seen any question, to be honest. Okay, from this particular type, which is called recursive descent. Okay, I mean you can have recursive descent here also. So I will tell you. So actually, this is not very important. Okay, if you want to study this, actually, I will just tell you. So basically, there is one already YouTube video I have taken. Okay, with backtrack. Okay, with backtrack I have already taken one video. This has got 4.8k views and it has got many nice comments, many nice comments. And let me tell you that for this particular type of parser, okay, there is based on my research, you can prove me wrong. There is only one video, okay, one video available on the entire internet, okay, for this particular parsing, okay, that is explaining this particular parsing in detail with 20 question, okay, only one video that is available. So anyway, so let's just come back. I don't want to digress much. Okay, so basically top down parsing can be done with backtracking, without backtracking. So we are interested in without backtracking. With backtracking, no question has been asked here. Okay, no question has been asked till now. But still we have actually, I have actually taught it. Okay, still I have taught it. So let's just see without backtracking, which is called predictive parsing. Okay, so by the way, both of this, okay, this is just a small thing that I want to convey because this is major misconception. People think that recursive descent is with backtracking, without backtracking. Basically, this recursive descent is just a recursive way. Okay, so both of this, either this or this, both of this can be implemented in the recursive or the non-recursive way. If you're implementing this in the recursive way, you will say recursive with backtracking. If you're implementing this with the recursive way, you will say recursive without backtracking. Okay, I mean both of this, it is just an implementation ways. Okay, these are not the types. People misunderstand that. They say that, okay, recursive descent parser is with backtracking only. Okay, recursive descent parser is with backtracking. You can even without backtracking also you can have recursive descent parser. Okay, this is just an implementation way. Recursive descent is just an implementation way. Okay, if you are implementing recursively, it is called recursive descent. Now this is the actual type. With backtracking or without backtracking is the actual type. Anyway, just coming to the point, which is these are few facts which I told you. Maybe if you have already studied, then you may be able to relate. Otherwise, you can just skip those 2-3 minutes which I told. Okay, basically I can say in very simple language, I can say parsing is of two types. One is called top down, another one is called bottom up. In top down we will study LL1, in bottom up we will study all of this. Okay, that's all. Okay, so let's start with LL1. This is also called as predictive parsing because we will do the prediction. Okay, predictive parsing. Okay, I mean this name is obvious. Okay, once you understand this LL1 parser, this name will become very natural to you, that why we are calling it predictive parsing. Okay, now let's start with LL1. So again, this LL1. So maybe I will just directly have the question here. Okay, so this LL1, which is called predictive parsing. So the parsing technique that about backtracking. Okay, so it is not a very good question because recursive descent, this parsing is basically can be implemented with backtracking or without backtracking. So it is not a very good question. So let's just directly first understand this LL1. Now to study this LL1 parser, we need to understand two concepts. Okay, so basically what I'm saying here is that we will study this. Okay, LL1 and these parsing techniques. But before we study, even LL1, we need to study two concepts. First is called first, and another concept is called follow. Okay, have you heard about these names, first and follow? Have you heard about these names before? Okay, maybe some of you guys, right? So let's just see what is the first. Okay, so basically I want to study, or I want to teach this LL1, but before teaching LL1 we should know first and follow. Okay, so let's just see what is first, and then we will see what is follow, and then we will be able to understand LL1. Okay, so suppose this particular grammar is given to you. Now if they ask you first of S, first of S is something which first can produce. Okay, so sorry, this S can produce. So S, if S is producing AB, then what is the first of this? A is coming to the first, right? So we will say it is A, and it is producing CD, so it will be C. It is producing DC, so it is D. Okay, so first of S is ACD. Is this understood to everyone? Is this understood to everyone? Okay, now let's just see more example. Probably you will get to understand everything, right? Tell me first of S here. Okay, what are the first of S? This is A, this is B and C. Because A, S is generating this, so what is the first of this? I mean, what is the first symbol? A. What is the first symbol here? B. What is the first symbol here? C, right? So you will say this is ABC. Is this understood? Okay, no, this is not a function, this is a grammar. Okay, you are saying first of S. Yes, you can say first of S is a function. Okay, I mean, this is a function that is returning a set, or you can, I mean, this is your notation. You can say this is set. Okay, I mean, you can compute it using a function, and finally this is set. Okay, or you can say this is a function which is returning a set. Anyway, this notation or this nomenclature is not very important. You can call it a function, you can call it a set. Okay, but is this understood? This is ABC. Now tell me here first of S and first of A. Tell me these two quickly. First of S is very easy. A and small b, I think, right? Small a and small b. First of A is also very easy. Small a, small d and small f. Small a, small d and small f, right? First of A and first of S, I hope that is clear to everyone. Okay. Now here tell me what is first of S, first of A. See, first of A is actually comparatively easy. This is small a, and since it is generating epsilon, so epsilon also will come in the first of A. Okay, epsilon also will come in the first of A, since it is generating epsilon. Is this fine to everyone? Let me know. Now first of S, since first of S is generating, right? Sorry, S is generating capital A, B and small a. So from the second production, it is clear it will be small a also. I mean, small a will anyway be there, but this is interesting here. So what is the first of AB? So you will say this is actually containing first of AB also. Something like this. Basically, I mean, I need to solve this further, but yes, this will be first of AB. Now, what is this first of AB? See, A, what is the first of A? It is anyway small a and epsilon. So if you put small a here, it will be first of small ab. But if you put epsilon, this will be epsilon b, which is nothing but b. So first of ab is small a, and small a is anyway there, so it is not useful for us, right? I mean, from this you can say this a can be small a or epsilon. Small a is anyway there with us, but if you put this as epsilon, then it is giving you b. So this first could be small b also. So finally you can say this is small a and small b. This is important to understand. Okay, small a and small b. It is not epsilon. Until and unless S generate epsilon, it cannot be epsilon. Okay, so anyway, you will get to understand this first later on. Okay, when we take more examples, because this understanding first is actually very very important, right? Let's just take this. What is the first of capital S? What is the first of capital A? What is the first of capital B? This is easy, I think. Small a and small b. Actually, everything will be easy. Don't worry. Okay, this is small a, small b. I think first of B is also very easy. So let me write it down. C, D, E, F. Right. First of A has small a and epsilon because it is directly generating epsilon. That is the only reason the epsilon is there. I mean, it is generating epsilon, and small a is anyway there. Now it will be first of capital A and B. Right. First of capital A and B. Is this fine to everyone? Now, what is the first of capital? I mean, this capital A is basically epsilon. If you put epsilon, this will be first of B. What is the first of B? So everything which is there in the first of B will get copied. Okay, if you put epsilon, and if you put A, it is not useful because A I already have, right? So basically, this will be finally epsilon A and everything here, which is C, D, E, F. Is this a little bit understood? Maybe with the more examples it will be clear. So what I'm trying to say here is that whatever it is generating, right, whatever it is generating, and then if it is having the non-terminal, right, then you will take first of that thing. Okay, and if you take first of that thing, you keep on plugging here. So basically basically to solve these kind of questions, okay, so maybe, okay, let me take little complicated question, but let's just first solve these because these are easy ones. Okay, first tell me what is the first of E, and then first of OP. I think these are the only non-terminal here, right? See, it will be tricky only when it is having epsilon. Is this grammar having epsilon? If the grammar is not having epsilon, then it will be always easy. Okay, comparatively basically. So you can say it is generating int, it is generating this, right? So these are the only two productions, so it is actually easy. So int, comma, this. And what about this? OP is generating plus star. These are the only two productions, so that is all right. That's easy one. Let me know. Let me know if that is understood to everyone. Or there is any doubt. Okay. Is this understood? Let me know quickly. Okay. Now let's take the next example. Okay. Let's take the next example, which is this. See, whenever grammar is having epsilon, okay, whenever grammar is having epsilon, then probably, I'm not saying always, then probably it is little harder. Uh, Someone is asking, how do we know int is a token? This is the, I mean, this is from the context, it is clear that int whole thing is like int, okay? It is not I, it is not I, okay? I mean, this from the context, it's, I mean, they will tell you that int is a terminal, but the more you see these kind of grammars, it will, even if they don't tell you, from the context, it is clear. It is not I and T. These are not three terminals. This is just one terminal. Okay, that's the reason I've written is int. I've not written just I. Okay. Otherwise, if these are the three terminals, then I could have just said I. Okay, they will give in the question in that case if there is any possibility. I mean, the options will not be just having I. Okay, it's not like option is just having I. Okay, it will never be the case. Okay, from the options it will be clear at least. See, if the grammar is having epsilon, then only there will be little bit of problem. So let me just tell you very nice trick here. Okay, the trick is that you have something called as nullable symbols. Nullable symbol is something, it is not a trick, this is a standard approach, which standard approach which all standard resources follow to find. Follow is, I mean, this is something we will study, but this is the English follow, okay, to find first. Okay, this is not a trick, this is a standard approach, so which all the standard sources actually follow. See, what we will do, we will first find the nullable symbol. What is the nullable symbol? If a symbol is finally generating epsilon, okay, if any symbol is generating epsilon in one or more production, it is called nullable. See, this x is directly generating epsilon, so x is nullable. Okay, x is nullable because x is generating epsilon. And what else is generating epsilon? You just write all the things which are generating epsilon. X is generating epsilon. Okay, maybe indirectly or maybe indirectly. Okay, is bi generating? Bi is actually directly generating epsilon, right? Bi is actually directly generating. Is E generating? See, T is not generating because it is always some terminal. So T is not generating. If T is not generating, so E cannot also generate. So only two are nullable, right? So always first write the nullable symbol. Okay. See, for this you might see that okay, this is very easy question. You can easily do without this standard approach. Okay, but if I give you complicated question, then without using nullable symbol, it will be very much confusing. That is why always first write the nullable symbol. Okay, before finding first or follow, this is the step one. This is the step one. Just take it as a step one. That always first write the nullable symbol. Nullable symbol are the symbols which are producing epsilon directly or indirectly. Okay, you can put a star here. Star means directly or indirectly. I mean, in either one production or maybe multiple productions. Okay. Now, let's just find the first. So first of, let's just find first of E. Okay, or maybe the very easy is first of T, right? Which is directly visible, which is this and int. Okay. Now let's just find first of E. First of E is actually directly from first of T, first of Tx, and since T is not nullable, you can directly copy. Okay, because it is not nullable, so it's not an issue, right? Now let's just find first of X. So here it is actually easy, plus and epsilon, and first of Y will be multiplication epsilon. So here this nullable is not much useful, to be honest, but in some questions I will tell you the questions where this nullable will be very useful. Okay, so let's just solve the questions which could be more complicated. Okay, before moving to the follow set, maybe I might be having the questions which are actually comparatively more complicated. Okay, for example, let me take a question which is comparatively more complicated. Then you will realize the importance, okay, of this follow set and all, this nullable symbols. Okay, this is okay, I don't mean to take very complicated, but this is the only example that I have as of now. Okay, let's do it. Okay, let's find out nullable symbols first. What are the nullable symbols? A, B, C are nullable. Is S is also nullable? Yes, I think S is also nullable because it is giving BC, right? It is giving BC. So B and C can be null. So that is why all the symbols S, A, B, C, all the symbols are nullable, right? I mean, all the symbols are generating epsilon directly or indirectly. Is this fine to everyone? Okay. Now, let's just find out first of each of this, right? So we will find out. This is little lengthy question, but let's just do it. First of A, first of B, and remember everything is nullable. So actually when you write nullable, you have, in mind, you have, triggered that, okay, if it is nullable, you have to, take care of about the null. So maybe you can write anything first. Maybe see, this null will anyway be there because since it is nullable, so null will anyway be there, right? I mean, everything is nullable actually in this case. Now you can start with anything. So with which you want to start? Maybe let me start with anything. Maybe let's just say E or A. Okay, so it is having E, and then first of SE. First of SE, right? Is this fine to everyone? Now, depending on the first of S, since the first of S is null also, so here here, E is anyway there, right? E is anyway there. I mean, if you put null here, E is anyway there. So if so, basically this you can say here you will copy the first of S. Okay. See, it is actually first of SE. It is actually first of SE. But if you put S, since S is nullable, if you put S null, then it will be first of E, which is E only, right? So it is not much useful. I mean, null is not much useful. Okay. So that is why you can say it is as good as saying first of S. Okay. Here you can write first of SE, doesn't matter, but you will copy the first of S. Okay. You will copy all first of S here. So I'm removing everything else. I'm just saying, okay, you will copy whenever you get first of S, you will copy here. What about B? For B, you will say it is D, and then first of SD. So again, if you put S as null, see, this is first of SD, right? So again, if you put S as null, because S is nullable, right? If you put S as null, it will be D, so it is not much useful. So basically, you will say you will copy first of S here also. What about C? You will say that, okay, this is I mean, since it is nullable, so you will be having F, and then first of S. You will copy whatever the first of S is, right? And since S is null, so I have already copied F, and then first of A, first of AB basically. Since both are nullable, so you can say you will be copying first of A also, and you will be copying first of B also, because if you put this as null, so you will be copying both. So maybe maybe I can write it like this. So basically this is F. First of S will get copied here. First of A will get copied here. First of B will also get copied here. Right? Many things. Okay. What about S? This is anyway A. Okay. First of A will get copied. First of B will get copied, because these are nullable, right? Okay. And I mean, since these are nullable, so basically first you can write D. Okay. First you can write D. And then you can say first of A will get copied, first of B will get copied, because these are nullable. And then first of B, first of C. So basically first of A, first of B, first of C. Everything will get copied here also. First of A will get copied, first of B will get copied, first of C will get copied. Okay. Is this fine to everyone, what I'm writing? Little bit, maybe. Okay. So this is little lengthy question, but still, is this fine? Now, since you now once you write this, okay, individually, that okay, what is going to be copied, okay, individually once you write it, now you know that okay, here first of ABC, everything will come, right? So basically everything, whatever you have here, everything will go here. So this F is extra, so you will be having F also, right? And then first of A will anyway have first of S. So anyway, everything is having first of S, and S is having everything. So basically, all the first will be actually same in this case. Okay, all the first will be actually same. It is not too good question, but yeah, they may ask these kind of questions. So you can say here in first of S you will be having epsilon, you will be having A, you will be having D, you will be having E, because first of B will be getting copied, so you will be having all the small symbols will be there. A, D, E, F, right? All the small symbols will be there, right? And if there is no small symbol left, so I mean they won't contribute anything. So basically this is the first of S, and this is the first of A also, this is first of B also, this is the first of C also. So all the first is same. Okay, all first are actually same. Yes. So that's great, right? So I mean, people have given correct answers. Okay. So see here that Sumit is saying A, D, E, F, epsilon. Okay, for all cases. So he's saying for all cases, right? And proud Indian. He's. Can you tell me your name? Okay. So he's saying understood. Okay, great. Now let's just see follow set. Is the first understood to everyone that what we are doing in first? Okay, don't get confused with this much. Okay, what I mean to say, you will be basically copying. Okay, let's just have easy examples only, because they may at max ask these things. The first step is to have nullable, and then put the epsilon wherever it is nullable. Okay, and then if something, I mean it's very easy, right? If something is having this nullable, then in that case you, let's suppose if this is, I mean let's suppose this is X. Okay, I mean this is, let's suppose, x. Okay, so nullable, then you will say, okay, this is first of e. Okay, then you will be copying first of later on. Okay, that's all. Little bit probably you have understood, but anyway we will be solving questions and then you will be understanding it more. Okay, there are many questions that they've asked from first and follow. Okay, now next thing is follow. Follow is also very easy. It says that whatever this s is following, okay, for the start symbol, follow for the start symbol is actually by default dollar. Okay, this is by default for the start symbol. Understood? Now next, for what s is following, you just need to see what s is following. S is actually following small a, and then s is actually following small b. Is s following epsilon? No. So basically for the follow, you just check that, okay, what s is following, right? So dollar $ab is the answer here. Dollar $ab is correct answer here. Understood? Let me know if that is okay to everyone. Okay, so here just notice here that epsilon will never be in follow of any symbol. Okay, epsilon will never be in follow of any symbol. Okay, because see, no symbol, it's not like this. Okay, it's not like that. Let's suppose this is, it's not like that a can follow epsilon. There is no meaning about it, because because I mean epsilon is nothing, it is just an empty string, right? So epsilon is just a empty string. So no symbol can follow that. Otherwise you will say that, okay, always you can have the empty string in between, right? So this doesn't make any sense. So epsilon cannot be in follow of anything. Is this fine to everyone? Okay. Now let's just check the follow of all non-terminals here. So let's just check follow of E and follow of OP. Since E is a start symbol, it will be given in the question. So dollar is follow of this. And then you just check on the right hand side wherever E is appearing. So E is appearing here, right? What E is following? E is actually following OP, right? So it will be, you will say it will be first of OPE. Okay, it will be first of OP. I mean, it whatever it is following, OPE and bracket. Okay, first of OPE and bracket. So follow of E will be this. So E is coming here, and E is also coming here. Then follow of E will be closing parenthesis also. Okay, so you will say follow of E will be closing parenthesis also. So these are follow of E. Now obviously we will find out the first to find out the complete follow. And what are the follow of OP? OP is coming here only one time. It will be follow of, sorry, first of capital E and bracket. Okay, is this a little bit fine? Okay, so someone is saying, sir, गेट 2020 पेपर के 25 पेपर के सारे क्वेश्चंस कॉपी कर दिए कि एएमटी में. It was just for the fun. I mean, obviously we don't know what they will be asking, but yes, we can definitely have a wise guess. Okay. So कॉपी तो नहीं की है, मतलब we don't know. We never know कि कॉपी हो गए कि नहीं हो गए. Okay. Now let's just compute, right? So basically follow of OP will be follow first of E and then this. Okay, and then let me just, okay, so basically first of E and bracket, right? Since there is no null, so first of E is anyway intent this, right? So it will be easy. So this is nothing but int and this bracket. Okay, that's easy. Now first of OP will be any plus and multiplication. So this is dollar plus multiplication and closing bracket. Right? Is this understood to everyone? Okay. If it is confusing, let me take more examples. See, let me take more examples. Probably you will get to understand. See this diagram. See what this age following. This age following. Let's suppose in this particular tree, I ask you what is this a following. You will say small a, right? So age and follow of small a. What this age following now? If this is epsilon, then it will follow. You just bypass this, and then you will say it is following a, right? It is following a. It cannot follow epsilon, so it is following a. What this age following? So we will cover this case. So basically age following, since there is nothing after a, right? So whatever s is following, whatever s is following, a will follow that, and s always follow dollar, so that is why dollar is there. So we will cover this case anyway. So let's just have a step by step. Okay, what do I mean? Suppose you have something like this. Capital S gives capital A, small a, and then C, and capital A gives small b. Tell me, or maybe let me write like this. It is basically having, let's just have this simple example. Okay. Tell me follow of capital A. Tell me follow of capital S. Since S is start symbol, so dollar will be there. Now you tell me. See, A is following small a, so directly small a, right? And on the right hand side, A is not appearing. Don't worry about the left hand side. On the right hand side, A is only appearing at this production, right? A is following small a, so that's the only answer. S is following small c, so that's the only answer. So this is the answer of this question. Let me know if that is clear to everyone. Yes, dollar always appear. Dollar will always appear. Okay. Dollar will always appear in the start symbol, follow of start symbol. Okay. Reason you will get to understand. Okay, don't worry about the reason. You will get to understand when we understand parsing, because we assume that okay, our input, okay, our input, whatever input we have, let's suppose A, B, C, that ends with dollar. Okay, and ultimately this will be S only. So S will anyway follow dollar. So you will get to understand this when we start parsing. Okay, let's go to the next example. Suppose let's have a little bit easier examples first. Let's suppose this is the example. Can you tell me follow of A, follow of B, follow of C? Follow of A, you just don't worry about the left hand, just check the right hand. See, it will anyway be dollar, by the way. Okay, and it is not coming anywhere else, so dollar is the only answer here. Okay, what is follow of B? It is coming here. Okay, don't worry about the left hand, just check at the right hand. Okay, it is coming here, but it is following A, so you will say A, and it is not coming anywhere else, so A is the only answer. C is coming two times, D and C, D and A, right? So you will say A and D are the answers. Is this clear to everyone? Let me know. Is this clear? Okay. Okay. So these are the follow of this, right? Now it may so happen. Now let me just maybe little bit change this kind of grammar. Okay, so that you can understand more. It may so happen. Let's suppose this A is not there. Okay. Suppose this A is not there. In that case, can you again find out the follow sets? Okay. Can you again find out the follow sets? Let's suppose this A is not there. So, so it is directly following capital thing, right? Now, basically, see, follow of A is anyway dollar, right? Follow of C, since C, don't worry about this left part. C is anyway coming D and A, so it will not change. It will be A and D only. This B is coming here, and B is basically following capital C. So in that case, you will say first of capital CD. Okay. So follow of B will be first of capital CD. It will be first of capital CD. Is this understood to everyone or not? Now you break it down more. So first of capital C is actually small d only. So that is why this is nothing but a small d only, right? So you will say, let me even remove it, or maybe, so basically this whole thing, I'm writing it on the side, because ultimately it will be first of D only. First of CD, which is actually D only. So it was first of CD. It was first of CD, but since first of C is just D, so finally you will say it is just D only. So this is dollar, this is D, this is 80. Is this little bit understood now? Okay. Is this little bit understood? Now just take the same grammar. Okay. Maybe I will just modify it little bit. Okay. Maybe let's just have B here. Let's just have epsilon here. Okay. Little bit I'm modifying. Now let's just quickly calculate first of everything. Sorry, follow of everything. Follow of capital A. Follow of capital B. Follow of capital C. Okay. Let's just quickly calculate follow of all of this. So follow of capital A will be anyway dollar, because it is not appearing in any right hand side. Okay. And it is by default dollar, by the way. Okay, because it is a start symbol, right? Follow of capital B. Okay, before capital B, maybe I can find out follow of capital C. Okay, don't worry about the left hand. It is coming 2 times, so it is A and B. Okay, it is A and B. Now, interestingly, let's just see follow of B. Follow of B basically should be first of CB only, right? First of CB. Now it may so happen that this first of CB, if you check it, so C is actually nullable, right? C is nullable. So it is first of C is actually D also. So you will say it is D also. And since it is nullable, so that is why it is B also, right? First of CB is B and D. So finally follow of B will be B and D in this particular case. Is this okay to everyone? Because it is first of CB and C is actually D and can be epsilon also. So if it is epsilon, then first of CB is actually B, right? So BD. Is this understood? Let me know quickly. Okay. Okay. Now I hope you are understanding, right? Great. Now let's just find out. Okay, in this case, let's just find out follow of. I think we have done this example. Okay, we have done this example for the first, but let's just do it for the follow. So by the way, as always, even for the follow, let's just quickly list out the nullable. So you know X and Y are the nullable, right? X and Y are the nullable. Okay, now let's just find out the follow. What are the follow of E? What are the follow of T? What are the follow of X? What are the follow of Y? Okay, so these are the 4 symbols for which we want to find out the follow. Okay, anyway, the dollar will be there. Now for E, it is coming here, right? So that is why follow of E will be closing parenthesis and there is one more rule, okay, one last rule that you need to know about the follow. It is coming here, but there is no on the right hand side, right? Nothing on the right hand side. In that case, E will follow whatever X is following. See, if there is a rule like this, okay, A gives something, 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 B, right? If the non-terminal is appearing at the end, okay, then B will follow whatever A is also following. So follow of B will contain follow of A, okay? Follow of B will be, I mean, it will contain follow of A anyway, right? It will contain the follow of A, okay? So we will talk about it in more detail, but for now I'm giving you the example directly, a question directly. So here follow of E will basically be E is, okay, don't worry about the left hand. E is coming here. This dollar is anyway there. E is coming here. So it will be follow of X also. Okay. So you will say comma follow of X also. Understood or not? Let me know. Okay. In the previous question, why not first of CA? Because B is following CB. Okay, not CA. CA is just a production that it is producing. Okay, it is not following. So don't worry about this left hand. You don't even need to see that where this left hand. Okay, you just see, okay, B is here. B is following CB. Okay. Okay. Now what is follow of T? Follow of T will be first of X. Okay, it will be first of X, and T is coming here. That is why it will be follow of by also. So basically T is coming at two places. Don't worry about the left again. Okay, T is coming here. It is following this. So first of X and T is coming here. So that is why it will be follow of by. Okay, so first of X follow of by. Understood? And what is follow of X? Follow of X will be, since it is coming here at the, okay, it is coming only at the one place. So it will be follow of E. So follow of E. Actually, in that case, follow of X and follow of E will be same, because it is containing follow of X and follow of this is also containing. So it will be same actually. Okay. I mean, you can just say that it is just this, okay, dollar and closing parenthesis. Okay. Anyway, what is the follow of by? By is coming at the right hand side. By is coming only at one place, which is follow of T. It will be follow of T. Okay. So, so actually, if you notice, these two are basically containing each other. I mean, it is containing follow of X and follow of X is containing follow of E, right? So it is containing something extra, but anyway, it will get copied, right? It will get copied because it is containing the follow of E. So because of these two, you will say there is nothing. I mean, these are both are containing each other. So from this, you can say it will be dollar and closing parenthesis only. Nothing extra you will get here, and it will be also dollar and closing parenthesis only. So let me write with the different color the final follow. Okay, so this is dollar and closing parenthesis. This is also dollar and closing parenthesis. Right now, this and this, I mean, T is having follow by, and by is having follow of T, right? So that is why these two will be again same. So let's just first find out first of X. What is the first of X? First of X is just plus, right? And epsilon. So epsilon it cannot follow, right? So follow of T. See, T I have taken from this, right? So if it is epsilon, see, this is again little complicated example. So if first of X is there, first of X is actually plus, and since it is epsilon, so if you put epsilon here, then T cannot follow epsilon, right? Then in that case, it will nothing. Then T will have follow of E, right? T will be having follow of E. So it will be having follow of E, comma follow of E, right? So follow of E will get copied. All of this follow will get copied, and therefore it will be plus dollar and closing parenthesis. Okay, and these all get copied here. Understood? Yes. Again, this was actually again a little lengthy example, but I hope you are getting the point. Okay. So what are the final follows? Finally, this will be just these two. These are three. I mean, in these two, basically plus is extra. Okay, here it is plus is extra, and then dollar and closing parenthesis. Okay, these three. Here also plus is extra, dollar and closing parenthesis. These three. Okay, here plus is not there, dollar and closing parenthesis. Okay, so let's maybe do next example, and you will get to understand more. Okay, from next. So it is just a matter of practice. Okay, let's do some more example. Okay, for example, let's just do this. Okay, maybe actually it is just a matter of practice only. So let's just do this. Okay, answer is written here, but that's fine. Okay, that's fine. Let's just do this. See, what will be nullable? Let's just quickly find out the nullable. What are the nullable? I think this is nullable, and C, this is not nullable. And since B is not nullable, that is why only nullable symbol is S, right? Only nullable symbol is S. Is this okay? Okay. So only nullable symbol is S, right? Now, because it is going to epsilon, it is going to B, and B is not nullable, right? Sorry, B is giving S and S is nullable. So okay, B is also nullable, and since S or B are nullable, so actually all three are nullable. Okay, great. Now let's just find out the follow. But before finding out the follow, maybe we can quickly find out the first. Okay, maybe we can quickly find out the first also. First of S, it will be A and epsilon. Very easy. First of A, it will be B and whatever the first of S be. Okay, since S is nullable, so that is why it will copy all the things from S, and then since it is nullable, so first of B, right? So first of B also. So I will write first of B. So maybe first of B is actually C, and then whatever the first of S, right? So what is the first of S? Oh, by the way, all the things are nullable. So maybe I can write null also. So first of B will be C, C, and then whatever is the first of S. So first of S is, you are anyway getting A also. Here you will be writing first of B, because first of S and then first of B, right? So first of A will be whatever is the first of S, and if it is nullable, then first of B. So first of B, from this you will be having C. Okay. So is this fine? Okay. Now let's just find out the follow now. Okay. Follow of S. Actually, gate PYQs are comparatively easy. So from gate PYQs, it will be more clear because those are comparatively easy, I would say. Okay. So what is follow of S? Anyway, it is dollar, right? And then S is, don't worry about this. S is coming here. So follow of S will be follow of S. Recursively, it is not adding anything. So follow of S will be the follow of B and first of B also. Okay. So it is interesting that follow of S will be first of B, and from this follow of B also. So it will be first of B, right? And first of B and follow of B also. Have you understood this? That why I'm writing this? Okay, which you are asking, only plus is in the first of X. Okay, maybe let me just complete this example now. Okay, so first of B we have already found out, right? So if first of B is epsilon, if first of B is epsilon, so follow of S, right? If first of B is epsilon, then follow of S will be follow of A actually. Okay, so since first of B is actually epsilon, so it will be having, so from here you can say dollar AC, right? Dollar AC, and then follow of A. Actually, okay, so B is also there. So follow of A, I thought that all the symbols are covered, right? Follow of A and follow of B. Okay. So what is follow of A? A is coming here. So whatever is the first of S, right? And whatever is the follow of B. So first of S is this, and follow of B, and follow of B and follow of A will be same, because follow of B will be whatever is the follow of A. So follow of B will be whatever is the follow of A, right? Follow of B will be, because B is coming only I think at one time. So whatever is the follow of A, okay? And follow of A will be whatever is the first of S, and since S is nullable, so follow of S also. So basically everything is actually containing each other, right? So if you notice, everything will be just containing each other. So $AC is answer for all of this, okay? $AC will be answer for all of this. Again, actually the follow examples could be little complicated if we try to sir, follow value given on the right corner. Yes, follow values are given here. Okay, I mean these are the answers. So actually, if you try to create some grammar, then generally this becomes more complicated than expected. Okay, so it is better to take some gate PYQs directly where they have asked the follow. Okay, so maybe from these PYQs you will learn. Okay, so let's just solve these PYQs. So maybe they have asked 1, 2. I mean they have directly asked follow for 3, 4 PYQs probably, right? And then this concept has used in LL1 much more times. Okay, I mean in LL1 actually this concept is heavily used. Okay, and not just in LL1. Basically, this has been used in bottom-up parsing also. So let's just see what is the follow of these symbols. Okay, let's just solve this question. What is the follow of Q? Follow of Q will be, see, first write the nullable symbols. It is better to write the nullable symbols. R is nullable, right? And S is not nullable. It is just producing this. Q is not nullable. Only R is nullable, right? Only R is nullable. Okay, that's fine. Now let's just find the follow of Q, whichever is asked. So it will be, since Q is coming here, it will be first of RS. If first of RS is null, then it will be follow of P. Since first of RS is not null, so it is easy. It will be just first of RS. Okay. If first of RS could have been null, then it will be follow of P also. Okay, but it is not null because only nullable symbol is R. Is this fine till this point? Okay. Now, what is the first of RS? R is here. The first of R, basically, let me write first of R separately. It is W epsilon, right? It is W epsilon. It is easy. Okay. So it is W and epsilon only. So what is the first of RS? It will be W. And since it is epsilon, so that is why it is first of S. What is first of S? It is bi. So W and bi, right? So what is the answer here? What is the answer? C is answer, right? C is answer. Is this understood to everyone? Okay. Now let's solve more questions. You will get to understand more. See, gate PYQs are, as I'm saying, since these examples probably I don't remember if I, because this example I have taken from the lecture, so I don't remember if I've taken from some resources or I have created by myself. Okay, generally it happens that if you're creating by yourself, then the grammar is so complicated that if you find the follow, it will be too much mess up. Okay, but that's fine. Let's just see the gate PYQs directly. So let's just see this. Consider the given grammar below. Let A, B, and D are the indices as follows. Compute the follow set of the non-terminal B and write the index for the symbol follow set in the descending order. For example, if the follow set is this, then answer should be 3210. Okay. So they are saying write it in the descending order. So whatever you are getting, you just write in this index order. I mean, this was NAT actually. Okay, this was NAT. So let's just find the follow of B. That's what they're asking. So nullable symbols are B and D, and B and D are nullable, so that is why A is also nullable, right? So nullable symbols ABD, right? ABD. Now let's just find out the follow of B. Follow of B will be, since B is coming only at this side, so it will be D. See here, this is interesting. It will be first of D, right? It will be first of D, but D is nullable. That is why it will be follow of A also. So it is first of D, and it will also come follow of A. Is this okay to everyone or not? Let me know. Is this okay to everyone? Now, what is the first of D? First of D is actually a small d. Okay. So, an epsilon, but epsilon we don't take. So, it is a small d. And what is follow of A? Follow of A is actually small a, right? It is actually small a. So, very easy, right? So, D and A is answer, but since you have to write in this order, so 3 1, right? 3 1 will be the answer. Okay. You have to write in descending order. That's great. Okay. So, those who are answering, can you let me know if you are, the first time learner or you already know these concepts? Just want to know that if the first time learners are actually getting these concepts or not. Okay. Just want to know this. So, those who are answering, just let me know. Are you understanding these first time or you already know these concepts? Okay. Okay. Some of you are first time, right? Great. So I hope you're getting right. I mean, see, you see the gate PYQs, right? It's not too much here and there, right? It's very easy. Once you know the concepts, it's very easy. Okay, great. Now let's just see this question. What this question is saying. Consider the following grammar. G has the three incomplete. Okay, this is basically the reverse question. So they are saying this question is very recent question. They have asked this in GATE 2024 only. So they are saying that if S is producing this, but one of the production is missing, T is producing this, but one of the production is missing, like this, right? So let's just do one thing. Let's just zoom it a little bit. Okay. Sorry. So basically, I can just copy this probably, or maybe is this visible, or should I just zoom it here? Okay, I can zoom it also. So what they're saying, the set of terminals are basically A, B, D, E, F, and the first and follow sets are non-terminals or so on. Okay, so they've given first and follow sets. Okay, they've given they try to or they actually have done some creativity. They've given the first and follow sets. Now they're saying which of the following option correctly fills in the incomplete production. Okay, that's interesting. Do you want to try this? Okay, do you want to try this? So they are saying that you already have computed first and follow, but the productions are missing. So which are the possible productions here? That is the question. So basically, you need to try this question with the option elimination because this is the best way. See, let's just start from D. Okay, if you are having uh, if you have SR in place of one, SRF, S gives RF. Okay, in place of one, if you have S gives RF. Okay, and in place of two, if you have T gives CT, in place of 3 you have R gives CR. Okay, see here the first sets are containing CDF, right? First of S is containing CDF. uh, by the way, null is here in the first of T and first of R. Okay, so if you have this R gives CR epsilon, so basically you will say that okay, see, this is satisfied. And then if you have this will be A, B and C. A, B and C. First of T will be having A, B, C. So but first of T is having A, B epsilon, so that is why you need to have something nullable here, right? I mean 2 should be something nullable. So basically D is not the correct answer because T gives, I mean, see, this has to be something nullable because you are having epsilon, right? Is this visible or should I again zoom it? So basically what they are saying, that if you are having, okay, if you are having something null here, right? Null in the C, if you are having in this T, if you are having null, then it should be something nullable. 2 should be something nullable. So so basically T gives epsilon. See, this option is wrong. So either A is correct or B is correct, right? A or B is correct because it should be something nullable. In both the cases, this 3 is anyway same. Okay, so let's just see this A. So first of S is actually CDF. Okay. So if you have A, if you have this B, then it will be just F, right? If you have just B, it will be just F. It will not be CD. I mean, it will not be having C if you just have this. I mean, you don't have to actually use the follow. Okay. I'm not using even the follow. Okay. I'm not even using this. Okay. You know that if you just have this, you will not be having a chance to have this C. So that is why this must be the correct answer. Why? Because for this two, you know that it has to be nullable. So either A or B correct answer. For this one, you know it has to it cannot have F. It cannot start with F. Why? Because it must be having C. So that is why A is the correct answer. From this optional elimination, you can do this. Okay. They tried this creativity, but that's okay. Understood? Okay. Now, let's move to the next question. Okay, so currently I don't have question, so we will move to the LL1 parsing. Okay, we will move to LL1 parsing. So this is the very first starting of LL1 parsing. Let me just remind you that what are the type of parsing that we have to study. So we have already discussed, but let me just bring that slide again. So basically we have just studied first and follow. Okay, first and follow are the two concepts which are needed. These are simple concepts only. Okay, don't worry about those concepts. These are simple concepts only. Those are needed for LL1 and also needed for these. Okay, so let's just start the very first parsing, which is called LL1 parsing. Okay, so LL1 means, let me tell you what does this LL1 means. L means you will scan from left to right, and you will do leftmost derivation. Okay, and you will just see one symbol look at. So you will get to understand meaning of this when we explain this, that what is this LL1. Okay, you will get to understand the full form of this LL1. Okay, L means you go left to right. Okay, and the input, and then you are doing basically leftmost derivation, and then basically you are just looking at one look at. Okay, you will get to understand everything. So let's just see this. Okay, let's just see directly with the example. Suppose this is the grammar that is given to me. Okay, and then they ask something called as LL1 parsing table. They are directly asking me something called as LL1 parsing table. Okay, so how to make the parsing table? Let's just see this. So you will be writing all the terminals, all the, see, this S is the non-terminal, all the terminals including dollar here. Okay, on the column. In the column, you will be writing all the terminals including dollar. In the rows, you will be writing all the non-terminals. Okay, so this is the first step. You will understand, don't worry, you will understand what is happening. So basically, what is this parsing? It is a top down parsing, right? I mean, basically, let's suppose you are having here, this is A and then B, I think AB, right? So you want to check whether AB is in the grammar or not, right? Or in the language of this grammar or not. You want to check something like this. For this, we have to have some parsing table. Let me first tell you step by step that how to make the parsing table and how to use this parsing table. Okay, we will have these two steps. So each of this production, okay, will go to one of the cell. So for example, let me just first tell you, this particular production will go to first of AS. First of AS is just A only, so it will go to S gives AS. S gives AS will will go here. Why? It will go to the first of this. First of this is A. This will go to the first of B, BS. So BS will go here because first of this is this. Okay. Now where will it go? It will go to, if this is epsilon, if this is epsilon, let's suppose the first of this is epsilon, it will go to the follow of S. Okay, follow of S is anyway, I mean, S is basically dollar. So you will say that it will go here. Okay, it will go here. So what is happening? Basically, each of the production will go to one of the cells. Okay, will go to one of the cells, right? This is first. This will go to the first of AS. This will go to first of BS. This will go to first of this. But if this is epsilon, then it will go to follow of this symbol. A follow of this is actually dollar. Okay. Is this understood? Now this is called a parsing table. Okay, this is called ll1 parsing table. Okay, this is called ll1 parsing table. Now what does this mean? Okay, how it is useful, let's just check. Okay, let's just check in the next slide that how it is even useful and what does this even mean. Okay, so little bit you might have understood that how to make the parsing table, but now let's just see that how to use this parsing table and what does this mean of having the parsing table. So basically our whole goal is to parse the string. Suppose there is some string. Okay, there is some string which is AA and let's suppose BB. Okay, this string you want to parse this string. Okay, suppose you want to parse let's first parse intuitively. Intuitively means that by just random try. So you will say okay AS and probably again AS, I mean this A is anyway as it is, then from this S you will say A is anyway as it is, BS, right? And then from this S you will say okay AAB is as it is, B BS, and then this is null, right? So AABB. Is this okay to everyone? Intuitively, most probably you will do this kind of top-down parsing. Is this okay? How many of you can do this? This kind of top-down parsing, how many of you can do this? Okay. Okay. I think most of you, right? Most of you can do this kind of top-down parsing. But we want to parse using this parsing table, okay, not intuitively. So this is something which is like I can say intuitively, or this is something which is our guess or something like this, right? But we want to make use of this parsing table to have the same tree. Let's just see how we can make use of this parsing table. So basically, what we will do, we will say, sorry, we will say this S, okay, starting with S. Now you want to generate, okay, you just be dumb, okay, you just be dumb and use this parsing table. Okay, be dumb and use table. Okay, so what do I mean by that? Let's just see. Okay, so I mean you don't worry about anything, you just use table. How to use table? I will just show you. See, you have this in your hand, isn't it? I mean this is first thing which is you're starting. So you can say this is in our hand, right? This is in our hand. Yes, so I will tell you what is the significance of this table. Okay, so now this is in our hand. Now you want to basically produce what? At first you want to produce a small a, right? So if this is in our hand, okay, this non-terminal is in our hand, this is we want to do. Okay, then which production to use? It is clearly screaming that okay, use this. Okay, so basically it is clearly telling that use this. Okay, use this. If this is in our hand, these things are in our hand, in hand. Okay, and this is what we want. Okay, I mean using this, if we want to produce A, then which production to use? If we want to produce B, then which production to use? So this is what it is telling. So basically if we want to produce this small a, then which production to use? This one, right? Now this A and A getting cancelled out. I mean you just need to basically produce this remaining. Now this is in our hand and we want to produce this small a. Just look at the symbol, this small a. Now this is in our hand, you want to produce a small a, which to use? Okay, so it is screaming that okay, use this AS only. Now this is getting cancelled out. Now this is again in our hand, right? And you want to produce a small b. So which to use? This is in our hand, you want to produce a small b. So it is screaming that okay, you use S gives BS. Right? So B is B getting cancelled out. Now again this is in our hand. You want to basically produce this. So basically it is saying it is in our hand. You want to produce this. So basically use this, right? Again BS. Now B will get cancelled out. This is in our hand. So basically it end with dollar. Okay, end with dollar. This is in our hand. You want to produce this dollar. This is in our hand. You want to produce dollar. So use this epsilon. Okay. Is this little bit clear to everyone or not? That how we are using this table? Okay, because using this table is very important, and really experienced know that how to use this table. Okay, really experienced know. So let's do more example, and you will get to understand it more. That what do I mean that how to use this table, right? Or maybe in the same example itself, let me just give you, different string parsing. Suppose suppose you have AB dollar. Let's see. I mean, intuitively you can do, but let's just see using the table. So you start from S. Now you are getting confused. Okay, which one to use? AS you should be using, BS you should be using, epsilon we should be using. Which one you should use? Tell me. You know that okay, AS to use, but is the table telling you same? Using S. If you want to produce A, then which to use? This one, right? So it is telling you that okay, go to AS. Now A is can cancel out. Now using S, you want to produce B, right? You want to produce this B using S. So just go to the table. Take the help of table using S. This is just like a Google map. Okay, you just use this as a map, right? So using S, if you want to produce B, then what to do? Using S, if you want to produce B, use this SB. Okay, so it is telling you that okay, use this SB. This is just like a map. BS, sorry, right? So B we get cancelled out. Using S, if you want to produce A, using S, if you want to produce A, so use this, right? So it is telling you again and again that okay, this is getting cancelled out. So AS. Now A getting cancelled out. Using S, if you want to produce B, using S, if you want to produce B, then what to do? Using S, if you want to produce B, then basically produce BS. Now BB get cancelled out. Using S, if you want to produce again dollar, then what to do? Using S, if you want to produce dollar, then epsilon. That is how you can make the tree using the table. Is this understood? This table can help you a lot. Exactly. This is so Washim is saying that from the table we this table is actually this is the only the sole purpose of the table in the life. Okay, so he is telling that from the table can be saved that which rule to use. Exactly, this is the sole purpose of the table. Okay, this is sole purpose, right? So maybe just one last example. Okay, I mean we will be having more examples, but just for this particular map or this particular parsing table, just one last example. Suppose you want to produce, okay, you want to produce A B A anything, okay, B, okay. So basically any mixture. Okay, let me just start with B this time. B A B. Suppose this is string. So using S, see, you know, as a human, you might be knowing, okay, I don't care if you know or not, okay, but as a human, you might be knowing, okay, out of these three options, probably this is the best option here, right? As a human, you know, but let's just take the help from the map. So using S, if you want to produce this B, okay, if you want to produce this B, then what will you do? Using S, if you want to produce this B, then use this BS. It is telling you again and again. Now B getting cancelled out. Now using this S, you want to produce this B. So using this S, if you want to produce B, so it is again telling you use this BS, right? So BB get cancelled out. Using this S, you want to produce A. Okay, you want to produce A. So it is telling you, okay, use this AS. Now A is getting cancelled out. Using this S, if you want to produce this B, so what to do? Using this S, if you want to produce this B, so use this BS. B getting cancelled out. Using this S, you want to produce dollar. Using this S, if you want to produce dollar, it is telling you again and again, use this epsilon. Okay, and that is how you can parse. You can say, oh wow, it is actually in the grammar. Is this understood? Okay, let me know if that is understood or not. Okay, so so it is actually very much needed to understand. Okay, now let's just make a table for this. Probably you will get to understand more, right? So how to make table? See, to make table, first you have to write S, I mean all the non-terminals here, all the terminals here, A, B, small c, including dollar. Okay, all the terminals here. Is this fine? Now for each of the production, okay, where to go? This production will go in the first of this. Okay, since S is nullable. Okay, is there no production for A? Most probably this is a production for A. Okay, maybe this is a typing mistake. Most probably this is a production for A. Okay, now let's just see this. So suppose we have this particular grammar. Okay, and now we want to parse. So basically we will say this particular thing will go to first of capital S, capital A and small a. So capital S is anyway nullable, right? So what is the first of capital S? So maybe I can just find out the first of capital S first. It is null. And then first of capital A, right? So first of capital A will be this SB. From this you can say it is B. And since A is also nullable, so this is C also. Okay. And since S and A both are nullable, so this will be A also. Okay, because both are nullable. So it will be A, B, C, epsilon. Okay. And what about first of B? First of A, this will be whatever is the first of S and null. So I think they will be having same. Okay. So or maybe I mean we can do for this, but maybe actually these are the standard grammar. So maybe I can just have parsing table for this, because these are the standard grammars. So I think this is the example that I might have taken, but probably let's just do for this. Okay. So what they are saying, that suppose we have something like this, right? And you want to make the parsing table. Okay. So these are the standard grammar. So I'm using the time to have the parsing table for the standard grammars. Okay. So let's just have all the terminals here. Okay. Maybe let me draw it completely. Okay. So where will this go? This will go to E gives int. I mean, see, the row is E and the column is basically the first of this, right? Where will this go? It is EG. It will go to here. E gives. Let me not draw it. It will not look very good. So E gives this, right? E O P bracket. Okay. Where will this go? It will go to OP row and then plus here, right? It will go to OP gives plus, and then this will go to OP gives multiplication. Okay. Is this fine to everyone? Is this fine to everyone? Now, suppose you want to parse some string. Okay. This is interesting part. Suppose you want to parse some string. Okay. Now, is this table making fine? Because for the table making, there has been many questions. Okay. From the table making itself, there has been many questions. Now, suppose you want to parse something. Let's suppose you want to parse some string. Okay. Which is int plus let's suppose int bracket. Okay. Now you start from the start symbol. Okay. So let's just do this. You start from the start symbol, capital E. Okay. Now which production to use to produce this? You will be confused, right? But immediately you have the answer. If you want to produce this opening parenthesis, okay, you have E, you want to produce the opening parenthesis, go to this, right? Go to this. So immediately you have the answer. Okay, opening parenthesis E, OP, E, right? And now you know that, okay, this will get cancelled out, right? This will get cancelled out. Now you have E in the hand and you want to produce this int. What to do? E in the hand, you want to produce this int. So basically you will be using this particular production, right? Int. Int will get cancelled out. Now you have OP in the hand and you want to produce this plus. So what you will do, you know this, right? You know this. OP in the hand, you want to produce this plus. So basically OP gives plus. So plus plus will get cancelled out. Now, okay. So you now have E in the hand. This bracket, I forgot to write it. Okay. Now you have E in the hand and you want to produce this int. So what to do? E gives int, right? So E in the hand and you want to produce this int. So you will produce int. E gives int. Int will get cancelled out. Now, yeah. Now you want to, so basically this anyway will match. I mean, you don't have any non-terminals left, so this will anyway match. Okay, this will anyway match. Okay, so this will anyway match, and dollar will anyway match. So basically, it is always a start symbol and dollar. Okay, you always start from start symbol dollar. I mean, dollar, you technically you don't produce dollar because grammar cannot produce dollar. Okay, you just say that, okay, see, in earlier cases I just said that if you want to produce dollar means you want to end yourself. I mean, grammar cannot technically produce dollar. Okay, it is just saying that, okay, I'm not producing anything. Okay, I'm just ending myself. Okay, so basically you always start from you don't have to produce dollar. You always start from start symbol and dollar. Okay, dollar will be anyway matched at the last. Understood? Let me know if you have understood that how to make use of this parsing table. Okay, now now let's just see this question. And for this particular, this is going to be interesting. For this particular question, can you make the parsing table? Okay, so maybe let me do one thing. Actually, the answer is here. So I will quickly just remove this. So basically, they have not written the whole production. They have just written the right hand side. Okay, which is good. Okay, so how to make the parsing table? Let's just see, right? So where will this production go? It will go in the first of tx, right? First of tx. So what is the first of t? It is this and this, right? So this production will go in opening parenthesis and an int. So this e gives tx, it will go in the int, or you can directly write tx because e gives is anyway by default. Okay, or that's fine. It will go in the int and opening parenthesis. Okay, where will this go? It will go in the opening parenthesis and int again. Okay, so it will go in the int. So this will go in the int, basically int y. Okay, and this will go in the opening parenthesis. T gives opening parenthesis capital E. Where will this go? This will go in the plus, and since it is epsilon, that is why follow of x. Okay, so this will go in the plus, x gives plus E, and in the follow of x. So what is the follow of x? It is same as follow of E. I think we have already calculated these things, right? So follow of x is same as follow of E, and follow of E is basically dollar and closing parenthesis. So basically this s is epsilon will go dollar and closing parenthesis. Okay, is this fine to everyone? Is this fine? Let me know. See, where will this particular production go? It is easy. Okay, it is easy. So you will just say it will go in the first of this. Okay, if this first of this is is epsilon, then it will go in the follow of x, and follow of x is anyway follow of x is follow of E, and also follow of E only. Follow of E is dollar and this closing parenthesis. So that is why I'm not writing x gives, because this is by default. For this particular row, x gives is by default. Is this fine? Okay, now let's just see where this will go. This is very easy. This will go in the star t. This will go here. Where will this go? It will go in the follow of by. What are the follow of by? Follow of by is actually here. Whatever is the follow of t, right? whatever is the follow of t, and t is actually having first of x, so whatever is the first of x, so which is plus, and if first of x is actually epsilon, then it will be, so basically let me write it. See, it is interesting, I think we have already done it. Follow of y is basically, it will go in the follow of y, right? So follow of y is here, it is follow of t, it will contain the follow of t, right? Follow of y will contain the follow of t, and follow of t is basically first of x. So from here you are writing first of x, and first of x is nothing but what x is producing is plus and epsilon. Since x is producing epsilon, that is why follow of t will be, since x is producing epsilon, it will be follow of e also. Okay, so you can say it will be, since x is producing epsilon, so that is why it will be follow of e also. Okay, and then this first of x is what, this is plus, and this epsilon I have covered. So follow of e I think we have already covered. This is dollar and this bracket, this is dollar and this. So this particular production will go to three places, plus, dollar and bracket. So this epsilon will go to plus, dollar and closing bracket, something like this. Okay, so yes, so I think everything is matching. Understood? So this is how we will be making the parsing table. Okay, now now can we do one thing? Can we, I mean, it's not needed, but just for the sake of one last example, can we have one string? For example, let's suppose this is producing tx, right? So let's suppose this, and then x is, okay, and then e is having, so basically e gives tx and t is having int, and x is having plus e, and then this e is tx. So I'm just having one string here so that I can just parse. Okay, maybe let's have very simple string. Let's suppose this is plus e, and e will be tx, and t will be int y, and x is null. So this is int. So maybe int plus int, int plus int. Okay. So can you parse int plus int using this? Okay, let's quickly do it. Okay, let's quickly, very quickly, let's just do it. I mean, it's not very much needed, but just for the sake of understanding whether we have understood or not. Okay, I want to parse int plus int. So how to do it? You have e in hand, and then you want to produce int. So you will be using tx. You have t in hand, you want to again produce int. Okay, so you have t in hand, you want to again produce int. So you will be using int y. So int will get cancelled out. You have y in hand, and you want to produce plus. So you will be just saying, okay, let's do it null. You have x in hand, you want to produce plus. You have x in hand, you want to produce plus. So plus e. Okay, so this plus and plus will get cancelled out. You have e in hand, you want to produce int. So again tx, again the same procedure, right? And then e in hand, and then tx from int by x, and both will be null. So like that you can basically make use of this parsing table. Okay, so basically using the parsing table is another thing, and making the another thing. Have you understood that how to make use of this parsing table? Okay, for any given string you should be able to make use of this parsing table. Understood? Okay, now uh, now let's just check whether this grammar is ll1 or not. So how to check? You will be making the parsing table. If the parsing table is actually having the multiple entries, then it will not be ll1, and you will get to now understand why that will not be ll1, right? So suppose you have x, y, z. Okay, I mean, these are the three non-terminals here, and the terminals are a, b, and z. A, b, z, and dollar. Okay. Okay. So where will this go? This will go. So at least actually this is easy. So let me just write whatever is the easy one. Okay. So x will, this will go here. Y gives b z. This will go here. So this is done. This is done, right? Z, this will go in the follow of z. So let's just do others. So two are very easy here. Now this will go in the first of by z. So first of by is actually b, and since this is epsilon, so this will b and z. So b and z. So this will go here by z. Okay. So this production will go at two places because this is containing epsilon. By is null level. So this is done. This will go to the follow of by. Follow of by is z only, right? Follow by is z only. So this will go to the follow by, which is z only. So epsilon here, right? This will go to the follow of by. This will go to the follow of z. Follow of z and follow of by is same. Follow of z and follow of by is same, right? So this will go to follow of z. So follow of z and follow by is same, and follow by is small z only, right? Follow by is small z only. So this will go something like this. Okay. So is this okay to everyone? How to draw the parsing table? Right. Okay. So this is how you can draw the parsing table. Is this LL1? Yes, this is actually LL1, right? I mean, if there are multiple entries, then it will not be LL1. But currently there are not multiple entries, so I will say yes, this is LL1. Okay. Now let's have more examples. Probably you will understanding more from those examples. Okay. Maybe we can directly do some PYQ. Okay. Let's just directly do some PYQ. So there are many PYQs that they have asked. So let's just do this PYQ. This has been asked in 2001. So maybe we can do this PYQ first. Okay. So what they are saying, these are the terminals. This is the grammar. Compute first and follow. Okay, and then complete the LL1 parsing table. So how to make LL1 parsing table? You have all the non-terminals. E and A are the only non-terminals, I think, right? So just write all the non-terminals here. Okay. And then write all the terminals here. What are the terminals? A and closing parenthesis, opening parenthesis. Okay, A and then opening parenthesis, closing parenthesis. Okay, plus star and dollar. Okay, so 6 are there, right? Great. Now where will this go? This is very easy, right? This will go at this place. Where will this go? This will, I think these are very easy. So this will go to, see, in gate they don't ask for complicated grammars. This will go to this. Where will this go? This will go to the row of A and plus, right? This will go to plus E and column plus. Okay, something like this. This will go to the into E. This will go to the follow of A. Follow of A is nothing but A is only coming at one place. So follow of A is nothing but follow of E. Follow of E is actually dollar, right? A dollar and this bracket. Okay. So this will go to follow of E. So this epsilon will go here. I hope that is a little bit visible, but I will be basic writing it here. Epsilon will go to the dollar. So let me write dollar here, little bit far. So here epsilon will go, and where will else this A gives epsilon go? Follow of A. So follow of A is actually, A is coming only at one place. Okay. Follow of A is actually follow of E. So E is anyway dollar. Follow of E is closing parenthesis, and follow of E is, yeah, these two, right? So so basically this is the LL1 parsing table. Is this okay to everyone? This is LL1 parsing table. Okay. So you see this? Yes, this is the LL1 parsing table, right? Okay, the same table that we are getting here. Now, okay, you can calculate first and follow. Now, actually, on top of this, do you know how to use this table? That is the another thing. Okay. Do you know how to use this? So, for example, suppose they say in this particular grammar, suppose they say there is some string which is a small a, capital A will give, let's suppose, plus, and this E, right? And capital E, A plus A. Okay, suppose there is some string A plus A. Suppose there is some string A plus A. Can you pass this string using this table? That is my question. Okay, I'm not going to do it. I mean, if you want, you can quickly do it. Given A, okay, given E, basically you first have this, right? A will get cancelled out. Now from this A, you want plus. From this A, you want plus. So you have this, right? So plus E, plus plus will get cancelled out. From this E, you want A. So you just have this. A will get cancelled out. From this A, you want dollar. So basically, I mean, you can't produce dollar. Basically, it means that you will use this production. Okay, epsilon. That's all. Very easily you can pass, isn't it? Okay. Is this understood to everyone or not? Is this understood? Okay. So now let's just solve this question. First and follow you can calculate. Okay. Now let's just solve this question. This question has been asking gate 2 and 3. What they are saying, they're just asking for two entries. Okay. In the table, in the predicting parsing table, they are saying that, okay, what is the entry for S dash and E? Okay. Which means there are many non-terminals. So S dash, there is E. For E and dollar only, they are asking. Okay. Okay, for this S dash only they are asking. So for E, it is very simple. ES will go here, and this will go where? This will go in the follow of S dash. Okay, this will go in the follow of S dash. What are the follow of S dash? This is same as follow of S, because S dash is only coming here. And what is the follow of S? This is same as first of S dash. Okay, and also follow of S dash. Okay. So basically, first of hash dash we need to find out, because follow of hash dash is not useful. So first of hash dash. So first of hash dash is E, and since first of hash dash, so this is a little tricky actually. Okay, since first of hash dash is basically epsilon also, that is why. So basically, let's just do it step by step. I want to know follow of hash dash, right? This is going to be interesting. Okay, follow of hash dash is basically, you can say from this production, you can say it is first of S. So for sure it is first of S. Sorry, follow of S. Follow of S dash is basically follow of S. Right? From this you can say it is follow of S. Okay. So follow of S is definitely dollar. Right? And there could be some other things. Right? So basically they are not much interested actually in the other things. So in this particular thing will definitely go to the dollar. Okay, so you can say, I mean, that's easy actually, you can say this. Okay, I mean, there could be some other things, but we are not much interested. So what is the answer here? Answer here is just A. Okay, answer here is just A, because there could be other things, but we are not much interested in those things, right? Okay. So I think only 2-3 PYQs they have asked. Okay, regarding the LL1. Okay, the straightforward PYQs they have asked, right? Regarding first and follow also they have asked. Those PYQs we have already solved. So if you notice that with regarding to the PYQ, they've actually asked very easy questions, right? Okay. So basically, let's just see that what are the not no, I mean, what are the grammars where you may face the difficulty, and those are the grammars which are not actually LL1. Okay, which are not actually LL1. Then you will get to understand more. Okay, so for example, let's just see this grammar. Okay, for this grammar, these are the non-terminals, right? These are the non-terminals. Now terminals are A and dollar. So this will go to just A. This is very easy. This will go where? This will go to the first of SA, right? What is the first of SA? So basically, what is the first of S? First of S is first of A only, right? First of A is basically this. So this SA will go here because see this at this particular entry you will be having 2. Okay, you will be having 2. Why that is the case? Because it is actually left recursive and it will be a problematic case because it will go to the first of S, and first of S is basically first of A, right? First of capital A, which is small a. So this will go to small a, right? And this will also go to small a. So for example, let's suppose you have this. Okay. Let's just try to make the parsing table for this. See, this is S, A, B, right? A, B, and dollar. See, where will this go? This will go to small a, right? And this will also go to the small a. That is the problem, right? That is why only one entry is containing, only one cell is containing 2 entries. And that is the problem here. See, why that is the problem? Because you will say that, okay, whenever you want to produce A, okay, from this S, you want to produce A, you will get confused whether to use this or this, right? So that is why this is not LL1 grammar, not LL1 grammar. Okay, this grammar is not LL1. Why? Because there are multiple entries. Okay, there are multiple entries. That is why this grammar is not LL1. Now, I think we have. Okay, we actually have more questions. Now let's just solve more questions, probably 1-2 more questions for the gate PYQs. Okay. So let's just see what this question is saying. For the given grammar below, the partial LL1 table is represented. Ensure that okay. Partial LL1 partial is also presented along with the grammar. Entries that need to be filled are indicated as E1, E2, E3. Okay, so they are saying this E1, E2, E3, these entries need to be filled. Like they have not filled all the entries. Okay, this is the grammar. Okay. First and follow for the non-terminals. So they are first asking first and follow. Actually, this has 2 parts. Okay, the part B, I think I have, and in the part B they are asking for E1, E2. Okay, E1, E2, E3. So probably you can do this question, right? So what is this E1? This E1 will be this entry, right? This entry will be E1, and whatever, where will this go? This will go in the follow of S, and follow of S is actually just dollar. So this is very easy, right? So this will go into follow of S. So E1 is just this entry. E2 is just this entry, right? What is E3? B, this particular entry, right? This particular entry will be in the first of S. So first of S will basically be containing this and dollar. So this is an epsilon. So A, B, and since it is containing epsilon, so that is why it will be in the follow of B. So B is following follow of B will be same as follow of S. So that is why this particular entry will be here also, because B has the dollar as follow. Okay, so even E2, E3 are easy to find out. Okay, now suppose they ask you to solve this question. So this question has been asked very recently in GATE 2021 only. So what they are saying, consider the following grammar, which is again, this is partially filled. Okay, some entries are missing, and now they're asking you to fill out these entries. Okay, let's do this question. This question has been asked recently, and then there are multiple easy questions. Oh, great. So yes, so I was just talking about this question. Okay, so this E1 is this, E2 is this, and E3 is this. We have just solved this question. Now let's just solve these questions also. So consider the following context-free grammar. Okay, so they're asking about this entry 1. So if you have S in hand, and then this particular entry D, they have written it. Okay, what will go at 1 and 2? Okay, it is not necessary that anything will go. So maybe it could be blank also. Okay, so they are having options with the blank also. Okay, so let's just check what will go in the 1 and 2. Can you tell me what is the first of RF? Since R is nullable, right? So R is nullable, so that is why it is basically C and then F. So it will go to C and F, right? So this particular entry will go to C and F. So you can say S gives RF. So S gives RF is basically, I think only one option is there where S gives RF is in 1 and 2. Only one option is there. So that's very easy question, right? Okay. This RF is basically C and F. So it will go to C and F both. So only one option is there where this is there. So easy question. Understood? Now let's just solve this question. In the predictive parser table M of the following entries respectively are. So basically they're asking for S gives ID. Okay. So see, this F is not nullable. So basically S gives ID is just this entry. Okay. So I think all the options are having this only. Okay. And what about R gives dollar? So R gives dollar will be probably this. Why? Because this will not never be this. It could be blank also, but we need to check. Okay. So R gives epsilon. So it will go to the follow of R. So what is the follow of R? Follow of R contains dollar, right? So that is why A is the correct answer here also, right? Because this entry will anyway go to ID. Okay, this entry will anyway go to ID. This entry will go to follow of R. This entry will go to follow of R. Follow of R. And follow of R contains follow of S. And it has dollar, right? So this entry will definitely go to dollar. And then that's what they're asking, that at dollar what will go. So that is why this is the answer. Understood? Now, this question has been asked very recently in GATE 2024. Do you want to solve this question? What they are saying, this particular grammar is given to you, and then again they are saying this is partially filled, and they are asking about these entries. Okay, so what will go to C? S gives C. So see here, since A and B are nullable, which is fine. If even if A is nullable, then also basically this entry will at most go to A, small a, and C. Okay, this entry will go to small a and small c. This entry will go to small a and small c. This entry will go to small b and small d, right? Okay, so at C and D, at C the first entry will go, at D the second entry will go, and A. Okay, so basically you can check which option is correct, right? So at 1 this will go, at 2 this will go. So either this is correct or this is correct. Now let's just check for other entries. For example, let's just check for this 3. Okay, given A, this will go to follow of A. Follow of A is small a and small b, right? This will go to small a and small b. So at a small b, yes, A gives epsilon will go. So I think A is the correct answer here. Okay, because this entry will go to small a. So basically, it is very very easy question. These are very very easy questions, right? Understood? Now, now basically, if you have understood these things, then it is fine for gate. You will be able to solve these kind of questions for sure. Okay. So how to solve these questions? You just have to check first and follow, and based on that, you just need to check that okay, which entry the entry will go at which place, right? Great. Now, given this, let's just see bottom up parsers. Okay. In bottom up parsers, these are multiple type of parser. Let's just see these step by step. Okay. First, let me know is this top down parser okay to everyone or not? Is this top down parser okay to everyone or not? Okay. Now let's just see bottom up parsers. or should we start the bottom up parsers in the next session? Okay. So maybe I think we have few slides. Okay. Maybe I can just talk about it in a little bit, okay? And then we will be continuing in the next session. Is this fine? Okay. So these are the bottom up parsers. Now let's just see how does this work. So as I told you that for the bottom up parsers, you will be starting from the string, let's suppose ABA, and you will be reaching to a start symbol, right? So suppose you have this ABA and you want to go to start symbol. So what will you do? You start from this left, okay? So by seeing this A, what will you do? You will say, oh, this seems to be capital A. This seems to be capital B. Okay, then you will say that okay, this seems to be capital B. Okay, this seems to be capital A, capital B. And then this ABA, okay, when you see this A, then you will say, okay, this ABA seems to be S, right? This ABA seems to be S. So that is how you will be starting from the string and then finally you are ending up with this S. Is this fine? Okay. Now, now let me tell you one more way. Okay. So you have S. Okay. I mean, this is not how the bottom up parser is working, but I'm just telling you. Okay. You start from S, but each time you are basically exploring the rightmost derivation. Okay. You just explore this B. What will happen? This B, if you just explore this B, you will do this. And now the rightmost non-terminal is only A, so it will be ABA, right? I mean, this is one more way. How we are doing it? We are always expanding rightmost, okay? Rightmost non-terminal, okay? And then I'm reaching. You can also expand leftmost, that's not an issue. But I'm just telling you, if you always expand rightmost, then also you are getting the same thing, okay? Why I'm doing it, you will just get to know in a while. So basically, this is how bottom up is doing, right? This is the bottom up way. This is how bottom up parser works. Okay. I will relate this thing with the bottom up parser in a while. Okay. Why I'm doing the rightmost. Okay. But yeah, let's just check. Okay. For the bottom up parser. So suppose this particular grammar is given and I want to parse this. Okay. And let's suppose you are starting with this, right? You are starting with this. Now, this is the string which is given to you. Now, with this string given, you will say, probably you will start with this A, you will say, okay, there is nothing, no non-terminal. Then you will have this B, okay? Then you will have this B. And for this B, you can probably say this is capital A, right? I mean, this B can be capital A. Then this A is anyway there. Then for whole ABC, you can say, okay, again, this is capital A, right? Again, this is capital A. Then this could be, you can say, see, for this is capital A. Now for these two, for this D, you can say this is capital B, right? D is capital B. Now you have, for this you have actually capital A, for this you have capital B, right? And then A and E are anyway there. So for whole thing, you can say it is capital S, something like this. So basically you are starting from the you are starting from the basically input string, and then finally you are reaching to the start symbol. Okay. Now if you do the rightmost derivation, okay, if you always explore the rightmost, let's just check what is happening. This is D, E, this is A, and capital A, if you want to explore, then in this case you will be going to capital A, B, C, D, and then this will give you, right? If you always do the rightmost, then also you are able to produce basically, right? But why I'm telling you to do the rightmost, let's just see this. Okay, so see here that this is the bottom up way, right? I mean, that's what we have done. But if you check in the rightmost what we are doing, if we just see this rightmost from the reverse, okay, see this ABA is first getting to capital ABA. Here also this ABA, okay, this A is getting to capital A. Then this ABA is getting to this B. Basically, you can say this B is getting to capital B, right? Here also this B's next step is to basically if you see this bottom up parser and you see the rightmost, there is one similarity. If you see the rightmost from the reverse, okay, rightmost from the reverse, then bottom up parser is exactly same. Basically, in the bottom up parser, we are doing this. Now you just see rightmost from the reverse. Okay, this A got changed to capital A. Yes, in the bottom up also. Then the next step in the reverse thing, this B changed to capital B, this B changed to capital B. Yes, right. And then this ABA changed to capital S. This ABA changed to capital S. Yes. So basically, if you notice here also, if you notice, see here in this case, first you are converting BBC to capital A. Sorry, this B to capital A, right? Is this you are doing here? So basically, you see here this B is if you see in the reverse, this B is converting to capital A, right? And then this ABC whole thing is converting to capital A in the reverse. So this ABC is converting to capital A in the reverse, right? And then this D is converted to B. So this D is converted to B. This D is converted to B. Basically, and then this whole thing is converted to S. So you can say what bottom up is doing. This is the same thing that we are doing rightmost derivation only. This is called rightmost derivation, but in reverse. Rightmost derivation. Okay. For example, see here. See, this is what bottom up is doing, right? You are starting from this. You are first converting like this, and then you are saying, okay, these three, okay, are converted to A, and then this and this, right? So this is the bottom up way, right? And the same thing we are doing in the rightmost, but in reverse. Okay. So let me just tell you again. So in rightmost, capital S is basically this is the grammar, right? And you want to produce this. So capital S is basically producing you. Now take the rightmost, which is capital B, right? So capital B, A, capital B can give small d. Take the rightmost, which is capital A only. So capital A can give you ABC. Capital A, B, C. I mean, it can give you something else also, but let's not worry about it. I'm just simulating, okay? Then capital A will also give you small b, right? Now you just see this rightmost. This is RMD, rightmost derivation. Okay, this is called RMD. Now if you see this from the reverse, so you will see that okay, this B is getting translated to capital A here also, right? In the bottom up also. Then this capital AB, this ABC is getting to capital A, right? In the reverse thing. Here also, this ABC, I mean this ABC is getting to capital A, right? And then this D is getting to capital B. Then this D is getting to capital B, right? Here. And then whole thing is getting to capital S. Then whole thing is getting to capital S. So basically you can say bottom up parser. This is just a small intuition. We will talk about it more. So, but you can say bottom up parser are nothing but rightmost derivation in reverse. Okay. So if you check, there have been few questions that the bottom up are also called LR, okay, or shift reduce. So which one of the following kind of derivation? Very very simple question. It is rightmost in reverse. LR, which means bottom up, it is rightmost in reverse. Okay. Now, which of the following derivation does the top-down parser have while parsing an input? Okay, so they're asking top-down. Top-down is basically leftmost. Okay, top-down means this. Here we always go to the leftmost. Okay, here we always go to the leftmost. Top-down is leftmost, right? Top-down generates leftmost. Okay. Now this is one interesting question. What they are saying, that given this particular grammar, okay, the number of reduction steps. Reduction means that whenever we are basically, these are called reductions. Okay, see, these are called reduction. Whenever we are basically reaching to some capital symbol, number of reduction steps they are asking you. I mean, how many how many such kind of these steps we have performed, right? So these will be exactly same as number of steps in rightmost, isn't it? Number of steps in right, I mean these two are actually same, if you notice. Okay, so if they're asking you in bottom up, how many for this particular string, triple A D triple B, for this particular string, how many times you have to reduce, or how many times you have to basically I mean if you start from this string, you have to do capital like this. Okay, this is called reduction. Then what to do? You basically you can do rightmost derivation here. Okay, so this is small a b, and then you just perform the rightmost derivation. For the b you just perform the derivation. It is just like this. Okay, and then you need to produce this, right? Okay, from this s it will be only so you will be having a s b, right? And then I mean if you keep on doing it, so basically if you keep on doing it, then you will say that okay, there has been 7 steps that are performed here. Okay, and the same steps you will perform triple a d triple b, the same steps you will perform if you even do like this. So let me just tell you. So first basically there is no reduction possible here. Then first you have to do at d, okay, which will be capital S, and then at b it will be capital B, like this. Okay, at d it will be capital S, then at b it will be capital B, and like this. Okay, so basically the only thing that I want to convey in this particular lecture about the bottom up is that although we will be studying it again, but bottom up parser is basically rightmost in the reverse. Okay, so let's just do one thing. Let's just have these parsings. Okay, all of these parsings in just one lecture. Okay, or in just one marathon. In the next slide, in the next lecture, we will be, or in the next marathon, we will be having all of these parsers. Okay, so I hope you understood what are the lexical analysis and all, right? So lexical analysis was the most interesting, I think, today. So I hope you understood these. Okay, so in the next session, we will be covering all other, okay, all other parsing techniques. Cool. So if you have understood, if you have understood the predictive parsing, if you have understood lexical analysis and all of this, just let us know in the comments. Okay, just comment it out and just let us know that how you liked it. Okay, if you have understood lexical, if you have understood parsing and all. Okay, so thank you everyone, thank you so much.